in science. As important as the answers are the new and never-ending questions. It is these questions and the researchers who ask them that allow us to advance our knowledge in all fields. Questions that help us understand and tackle global challenges such as climate change. Questions that lead to the discovery of new worlds and to the development of new technologies. Ciências ULisboa is an epicenter of science of excellence. Let's learn about it together. Welcome. Welcome, everyone. It is a pleasure to have you here, and we are looking forward to engaging and fruitful discussions today. Who knows, maybe today sparks the birth of a new world-changing idea. You might have noticed some updates in this edition, the 5th edition of this already emblematic event at Ciências ULisboa. In fact, we have decided to name it Ciências, Research and Innovation Day. Innovation is part of what we do, and it will be one of the main topics of today's interventions. But it will remain in our agenda for the coming days. We will celebrate the excellence of the research and innovation done by Ciências during the whole week, with activities organized by our several research units. So please check our webpage for all information and join us. And also stay tuned during today's sessions. Besides the plenary sessions during the whole day of today, throughout the day we will share with you some testimonies by some of our researchers who address global challenges such as climate change, energy transition, and artificial intelligence. So let's start. Let's welcome to the stage our Dean, Professor Luís Carriço.
Muito bom dia a todos. Good morning. Vice Rector, if you allow me, I will start this 5th edition of the International, of the Research and Innovation Day of Ciências. So let me start with the compliments. First of all, Vice Rector, presidents of the School Council, Scientific Council, dear members, the directors and presidents of other schools of the University of Lisbon, dear members of the School Council, of the Scientific Council, and of the Pedagogical Council, dear presidents of the departments of the University of Lisbon, of Ciências. Sorry, bear with me, I just wrote this in Portuguese, so I'm translating directly. The coordinators of our great research units, President of FCNCs of the Executive Council of the FCNC is not here, but I will greet it anyway. Dear representatives of the institution that collaborate with us, LOSAL, definitely, SPECO and Geopark Oeste, dear colleagues, teachers, researchers, students, and all the staff of the University of Lisbon, ladies and gentlemen. Be very welcome to the 5th edition of the Research and Innovation Day of Ciências. As you know, that's for sure, today we commemorate another day, which is the International Day Against the Climate Change that occurs every 24th of October every year. Strangely enough, or not, the Research Day of Ciências usually occurs on the same week over the 5th edition now. Is it a coincidence, or is it that our research here at Ciências is very much aligned with the problematic of the climate change? I would say the former. In fact, a lot of the great research that we do here, it's about climate change and all the things that are associated. We must not completely focus on that. Actually, I would say that all the research that we do here could definitely contribute to this specific topic. We'll go from the energy, the research on renewable energies, for example, or on sustainability, or on biodiversity, or in differential equations, because a lot of models are based on that, or on statistics, because definitely we use that in some of our models, or of course, why not, artificial intelligence. If I was forced, actually I was kind of forced that in the last meeting of the research units, if I was forced to say, what are the main lines, research lines, that we should adopt here at Ciências, I would probably say climate change, energy, and artificial intelligence. Of course, someone said in space, and some others would say something else. True, but I think we all acknowledge that it's a very, very important theme. Not just because we do great research here at Ciências at that level, but also because it's a theme that will define our future as mankind, personkind, sorry. Definitely we must be aware of that. Definitely we all must be worried about what happens in the next years. It's so relevant that last year one of the topics here was actually climate change. It will be this year with the convergence of 3 topics: energetic transition, artificial intelligence, and definitely climate change. Again, we are not stopping at that point. We do a lot of great work that either relates with that directly or indirectly, or some other research result, which is definitely very important. But we must, if we must focus, if we must pick something that's relevant for all of us and where we are good, why not pick these 3? And you can say, well, you are talking about artificial intelligence because you are from computer science and definitely you are picking your own research. That's not true. In fact, it was about 40 years ago when I had my first course on artificial intelligence, and I said, we are taping? No, I just said bullshit. Well, we just do a lot of rules, but all the knowledge was in fact in the human, not in the artificial intelligence. So that was a theme that I have never researched on, and unfortunately I was wrong, or fortunately I was wrong, because nowadays it's a very, very important topic in all the activities that we do. But we'll come to that in a moment. Okay, so last Friday I was lucky enough to make an interview, actually to be interviewed for some newspapers. And the topic was actually what science could do for climate change. And well, you can imagine I do not work in climate change. I do not work in energy or renewable energies. I do not work in artificial intelligence, but I have to say a couple of things. And I will briefly tell you what I've said. Well, science is crucial on what we expect in the near future. And I will say three or four themes that we are very good at Ciências that definitely could contribute to have a better future for the whole world. And in a way, I can sum them up in 3 words. The first is to understand, to comprehend actually what is the climate change, which are the factors that imply the change of the climate, what are the consequences, what can we do, and where it comes from. The second one is adaptation. Okay? How can we adapt to the climate change? Because it's there. There's no escape. We cannot stop with our hands. And then, how can we avoid the full collapse? So these 3, I believe, are 3 very important words on this topic. At the first, we definitely must consider the creation is the wrong word, of the information from data. Okay? How can we get very precise and true information that we can pass to all the scientists, but also to the public in general? It's not easy, but here at Ciências we do a lot of work on that. For instance, in the climate modeling. Okay? Climate modeling is crucial here. Okay? It's definitely something that allows us to understand where we are and where we might go. Okay? Of course, we must set out a set of scenarios, some with human intervention, some without human intervention, some that will go through a definitely serious problem, well, probably without humans in the future, some with some humans, or all of us, or well, some of us definitely will be here. Modeling is, again, a basic, very important theme on this aspect, to understand, to fully understand what we have. And here at Ciências, we are very good at it. And this involves a lot of research areas. Some of them that don't even know that are doing some research important for these areas. Then at the level of mitigation and adaptation. Here, we also do a lot of excellent work. Either as we regulate or transform the nature to the challenges of the climate change. How can we change that so that nature keeps going on in these situations? Do not be mistaken. Climate change is here. The climate has changed. We must adapt. There is no other way. And we have to build intelligent solutions, either based on nature or on artificial settings or on something else that allows us to live and not just survive in the next 10 to 20 to 50 years. What's the role of biodiversity in the stability and the resilience of ecosystems? Thank you, Cristina, for these words. Actually, some of these topics, some of the speakers helped me, because you know I'm not from the area, helped me to also understand some of the topics on this area. And I will thank, of course, Cristina and Miguel. Where is Miguel? Thank you, Miguel, and Cátia about that. So, at the last level, I would say solutions to avoid the full collapse. And again, renewable energies are a key topic. Again, we must not be mistaken. We are not going to reduce the consume of energy. We are going to grow and grow and keep growing. There is no realistic way, except for having a pandemic every year, that hopefully will not occur, to reduce energy. We are still wanting to have hospitals functioning at full speed, and we are not going to say, okay, we just, let's forget about cars or hospitals or planes, or let's live again as the man used to live 2,000 years ago. It's not going to happen. Okay? So we have to find new solutions. And here at Ciências, we do find new solutions. There's a lot of work on finding how renewable energies will keep providing us the energy continuously, because that's one of the challenges. You know, solar energy, for instance, it's very good during the day, but then we have the whole night too. And then we have batteries. Well, batteries may cause problems, and so on and so forth. How can we live with that? That's some of the solutions, actually very nice solutions. Hopefully Miguel will talk a little bit about that. Very nice solutions on how to do that. And finally, artificial intelligence. Okay, so, no pain today. Sorry. And then finally about artificial intelligence. Again, artificial intelligence is something that we are not going to stop. There are some debates about, let's stop ChatGPT and all the things that we have. Well, not going to happen. I think we have to look at history to understand exactly that. So what can we do on that one? So again, artificial intelligence provides, and that's the big difference between 40 years ago when we were talking about classic artificial intelligence, and nowadays. Artificial intelligence actually can learn, which is a big difference. It became actually somehow intelligent. And now it can learn very, very fast. So if it can learn so fast, maybe it could help us to improve our systems, to improve our solutions, to boost whatever we need to do, and we need to do something to stop as much as possible climate change. Okay, so certainly science is more, every day it's more multidisciplinary. We have to think about that, and these three topics are clear in this matter. We have to collaborate, we have to join efforts. And here at Ciências, we are lucky enough to have a lot of science, a lot of different science, and we must collaborate to do something which has a real impact in society and of course in science. I will finish just congratulating all the researchers in Ciências for all the great work they have done, and I think Margarida will talk a little bit about those topics. So I will avoid this year to say again, which is true, that we do the best research in Portugal. But again, congratulations, and thank you very much for your collaboration in making Ciências a great school, a great research and innovation school. Thank you all.
So I was just saying that I don't need an introduction, I can introduce myself. Okay, I'm the Vice Rector for Research and Innovation at the University of Lisbon. I know most of you in the room, and for sure you also know me. We are good friends. And if you allow me, I actually switched to Portuguese because I only have 2 words. I thought about them this morning, and I thought them in Portuguese. So first of all, this is actually the third word. I want to greet everyone in the room. Tomo as palavras do professor Luís Carriço, diretor da Faculdade de Ciências, para cumprimentar todos os convidados, todos os docentes, todos os investigadores, técnicos e administrativos e, naturalmente, estudantes também. Esta é a 5ª edição do Ciências Research and Innovation Day. Tenho que dizer que é a minha 3ª presença aqui, porque a primeira coisa que eu fiz quando entrei na reitoria foi precisamente vir ao Dia de Ciências, que foi nessa altura a 3ª edição. Eu tenho apenas 2 palavras, como disse, para deixar aqui. A primeira é a de que a urgência da ação exigida pelos grandes desafios globais que já foram hoje aqui enunciados, desde o clima, ao meio ambiente, à saúde, à inclusão, à segurança, à transição digital, à cultura, e certamente nas vossas mentes estarão ainda outros desafios, requerem uma centralidade constante destes temas no debate público e, consequentemente, também uma mobilização ímpar dos vários agentes da nossa sociedade. Incluo aqui, em primeiro lugar, naturalmente, a universidade, mas também o governo, os governos, as empresas, as famílias e os indivíduos, as pessoas. Segunda palavra é a de que a educação e a investigação científica têm uma especial relevância nesta luta que eu diria mesmo que travamos contra o tempo. E a universidade, como geradora de conhecimento, geradora de inovação, deve, de facto, assumir um papel de liderança. Espera-se esse papel de liderança. Aonde? Na investigação multidisciplinar, tal como já foi referido, num ensino transversal de temáticas atuais e relevantes, bem como também no exemplo daquilo que faz. E ciências é um bom exemplo de tudo isto. I wish you all a great day, a great celebrating day of science and innovation at the Faculty of Sciences. And thank you for inviting me to be here and for allowing me these 2 words that I just asked as I entered the room to say. Thank you so much, everyone.
Thank you, Professora Cecília. Thank you, Professor Luís. Let's start our dive into this day by learning about the highlights of our research during last year. For that, I kindly ask Professor Margarida Santos-Reis, our Vice Dean for Research and the coordinator of this event, to now come to the stage to share with you this and other exciting information with us. Just a few seconds, and here it is.
So, thank you very much. Thank you, our Vice Rector, for these kind words and for sharing, being present in all these 3 editions, and I hope that she will continue to visit us. Thank you all. Welcome all to this 5th edition. I'm going to speak a little bit. I'm going to make an overview of what happened during the last year. And some of the facts I'm going to present, the numeric facts, the KPI, the indicators, are related to the year of 2022. But of course, the examples that I select for presenting you as an overview of what we do in the faculty are events that occurred between the last edition and this last edition. So some are already from this year. As you know, it's very difficult to select what we do because we do such much things that it's really hard to try to, in 10 minutes, to say what we did in good science in the faculty. So I hope I have selected some of the examples that give us or illustrate us different types of activities that we perform. I may be a little biased for biology, for life science, not biology, for life science, not because I am a biologist, I must say, a little bit maybe, but also because this area, the life science, is one of the strongest in the faculty in terms of number of research and students. So therefore it's much more easy to use examples from them, but I've covered all the scientific areas. É só assim? Okay. So for those that are here for the first time, let's just tell you about the research and innovation environment of the faculty. So we have 7 scientific areas that covers exact sciences and applied science. We have an innovation hub, which is our Center for Innovation, the Tech Labs, and we also have a Sustainability Living Lab. I will not focus too much on the innovation side because we will have in this afternoon an overview what Ciências has been done in innovation and what are the perspectives for the future. But I will speak a little bit about the sustainability, and as I said, I will give examples of what we are doing in terms of research. I will start for the last. I will start for the last, not because we have been much more in these areas than in the research, but because today is the theme that we are using in this day, which is, of course, sustainability. And we are very proud of just having launched our first report, sustainability report of Ciências. It's already available. It's in Portuguese and in English. And I'm sorry, but I skipped this. And of course, in this report, what we want to demonstrate is that Ciências is really committed with sustainability. And in this particular day, which is about research and innovation, of course, I gave you here 2 examples that were present in the report about how our PhD thesis, which is one of the main motors of research in the faculty, and how our research projects illustrate well how we are dealing with all the sustainable goals, development sustainable goals. Of course, as you can see, most of it are related with climate action, with biodiversity, either in water and in land, but also, of course, education of quality, and a lot with innovation. This also translates into several projects that we have here in the faculty that are exploratory projects that are in place, and that also represent how we are dealing with all these sustainable goals and how we are contributing with our actions to that. And just a note to call you the attention that is now open a new contest for ideas for sustainability, which is an initiative of this directive board that aims to involve students, researchers, professors, and non-teaching staff in projects that are dealing with sustainability. Entering directly on some of the facts and figures about Ciências research and innovation, I'm going to present again, as always, the indicators for 2022. I will not go into all the details, but I call your attention that the number of scientific papers that we are publishing are increasing every year, and especially the quality of the papers that we are publishing is also increasing. In 2022, 85% of our papers, more than 85% of our papers were in the top ranked journals. And I will say that around 70 are in the first quartile. And also another thing that I think it's worthwhile to mention today is the number of grants that we are being awarded in top-level funding programs that fund our research. And also the number of cooperation protocols, which is really, really high. The money that we gather for all these research and innovation areas in the faculty is increasing also, but specifically what I want to show you here is that we are being able to increase every year the funding that we can attract from European funds. So we are no longer dependent on the FCT, which is good, as you know, because FCT is having each year less money. And we are really increasing our attraction of funds at the European level, which is really a good news. But what is important is not only that we publish the papers, but that what we publish has an impact. And one of the main or important indicators that we have is this top ranking of the 2% researchers that publish in the world, which is made by Stanford University. And again, every year we are increasing the number of researchers of the faculty that are in these lists. In 2022, the list just were publicized, and we have 26 scientists in this top 2 world ranking, 19 with impact in 2022, and this is made basically on the number of citations of their papers, and 20 with a career-long impact. We have here the lists. What is most important, and I'm sorry that I could not be able to show all the faces of these people, but I'm sure that you know most of them, is that of the 7 scientific areas that we have in the faculty, we have researchers of 6 of our scientific areas listed in this ranking. And also, of the 19 research units that we have in the faculty at this moment, 11 are represented in this list. So this really represents how good we are in the world, and that we must be proud what we do in the Faculty of Sciences. These are the top 2 scientists, 22, and these are the career-long scientists. Some are common in both lists. And again, as our director said, congratulations to all. And we, as the directive board, are very proud of being able to congratulate you all. But it's not only at the international level that we are awarded. Also, in the UL Scientific Prizes, we had several people that were awarded with the first prize in different areas, as you can see here, and also in honorable mentions. Again, Faculty of Sciences is always represented in every edition, and researchers from the faculty are always. In this case, I made a special word to the CQA and to IDL by being able to have several researchers awarded in this sense. And also importantly, because of the importance that the Academy of Sciences has in our country, we also have several colleagues that were awarded and that were nominated, more than awarded, they were nominated for the Academy of Sciences in different roles. These persons were entered the Academy of Sciences or were elected or nominated in 2022 and also in 2023 already. And a special word to Miguel Miranda, that was also awarded with a Gold Merit Medal. It was, of course, by his role as a president of IPMA, but we must not forget that he's alumni of the faculty and that he was nominated as the president of MIPA because of the science he produced, the knowledge he gathered, and all of it was in the Faculty of Sciences. So again, we must be very, very proud of that. And now going into the highlights that I selected. And again, remember, I selected these examples just to give you a diversity of activities that we do in research and innovation. And there is a mix between science and innovation. And I will start by the chemistry for health sciences. So again, there is CQA as a project that emerged from a spin-off year of Sciences that has developed novel drug to battle against breast cancer. Breast cancer is one of the topics where the Faculty of Sciences has an enormous research being done, not only by CQA, but also by IBEB. And here I selected this example from the Biophysics Center because it's an exploratory model, project, that emerged from a previous project that was a previous research that is developing an experimental evolution to use microwave imaging system also to fight the breast cancer. And the importance of this study is because for the first time it will test it in human patients. And this is the first time in Portugal for the breast cancer, but is the unique so far as in the world for detecting or studying the axilla cancers. And it's a protocol with the Hospital da Luz. Moving into Earth and space sciences. Well, you all know that one of the plausible explanations for the extinction of dinosaurs in the past was an asteroid that collided with Earth and that lead to the extinction of dinosaurs. And again, this example, these are two works that, one work and one mention that was done in this last year, shows how we in the Faculty of Science are investigating both. We are still investigating dinosaurs and have a leading role on the study of dinosaurs in the Iberian Peninsula. And we are very proud to know that all the work done by Pedro Machado from our Institute of Astrophysics and Space Science was so important, or is so important, that they awarded and then his name to an asteroid because of his work in detecting asteroids, although he also does very good research and excellent research in terms of extraplanet atmospheres. Moving to life sciences. So as our director said, the loss of biodiversity and the crisis of biodiversity is one of the main topics that is one of the global changes that we have nowadays, and Cristina is going to speak about the importance of nature and related with the importance of nature not only for climate change but also for the biodiversity crisis. We are proud to say that we at Ciências were the coordinators of 3 of the red data books that were published in the last year. The red data books are very important instruments for decision making, for understanding the status of biodiversity in our country. And this was a huge task that was done by our researchers from 3 different research centers. As you can see, the number of species that were evaluated was extremely high. This involved dozens of researchers from our faculty, of course in cooperation with other universities. But the important thing is that we were the leaders of these red data books. And this was extremely important. And I also give a further example which emerged from the red data book for fishes, which is the development of a national information system on freshwater fish in mainland Portugal. That was an add-on to this project that, besides allow us to understand how is the conservation status of our species, also developed this tool that allows anyone to identify the species that they could find and being able to geolocate it and so understand which are the trends on their distribution. But with red data books, we are speaking about species that are threatened, species that we have to pay attention to it because of the functions that they have in the ecosystem. But we also have to deal with other, we also have to look into biodiversity as, for instance, a food source, and how we can use it. And it's important to manage these species. Here I select 3 projects that were coordinated by MARE, and I selected them just to show you how able we are to attract funds from different sources. So the first project, which is a project that is also still related with the threatened species, but is a threatened species that has a high economic value, and it's very important in gastronomy in the Mediterranean, which is the dusky grouper. And this project is funded by an enterprise or an NGO that is responsible for conservation actions, and that is paying a study to see how we can recover the populations in the southwest of coast of Portugal. But we also, or they, not me, they are also able to get a lot of funds from the MARE 2020, so a very important national funding program to study, for instance, invasive species, like this case is the Japanese clam, that represents around 25 million euros per year for the catcher, but that at the moment 90% are not declared. So the MARE 2020 paid to the team of the Faculty of Science to develop an action plan for the species management through fishing regulation and to solve this problem of illegal. Another invasive species that we have in Portugal, and this is causing a huge impact in ecosystems, is this catfish, which, as you can see in the image, and can get a huge size, and that is causing a huge impact in our aquatic systems, which, because of the location of the Iberian Peninsula and the history of the Iberian Peninsula, includes a lot of endemic species that are now threatened by this catfish. And the problem here is, again, a balance between economics and conservation, because this fish is very important for recreational and sport fishing, but at the same time is causing a huge impact on our biodiversity. And the reason why I selected is because, as you can see, funding for this project is coming from European funds, and therefore it represents how we are able to attract different types of funds. Moving for innovation and for technology, I selected this topic, which is the development of biotechnological solutions for the wine industry. And in this particular case, I think we should congratulate the researchers from BioEasy because of the great research they are doing in terms of investigating the vulnerability of grapevines, and therefore the wine that results from that, to several problems that these cultures have in our country. And here, I think it's nice to see how we are awarding, or we are receiving awards, not for researchers already with a consolidated career, but also to young students that cooperate in our institution with the teams, and therefore I think it's important to select this example. And again, continuing in technological solutions and representing a little bit of the computer science that we do, I think it's important again to speak about how we are collaborating or trying to find solutions to help to cope with several sustainability goals that have to do with the social dimension. And here I represent one paper that has been awarded in one of the most important conferences in computer sciences. It won the first prize, and an innovation side which was the Young Inventors Prize that was awarded to Felipe Rocha, one of our PhD students in computer science. In both cases, they are dealing with solutions for blind people and to get competencies in digital competencies, although they are blind, and therefore it's really both projects are really having an high impact in our society. And to finish, and in going into the mathematical sciences, I think it is also important, we have been speaking about the importance of science, how science is important to be recognized by the media, and therefore I selected this project from our Center of Statistics and Applications that has been doing a cooperation protocol with one of our main televisions, which is RTP1, where they have been involved in showing how data is important and how we can analyze our data and give to the media the relative position of Portugal in the European context. This was a huge protocol that started in 2021, continued by 2022, and according to Marilia, the coordinator of the center, they are now planning to continue with this protocol, and this it's really I think also a thing that is proud for us. And finally, going into history, well, I selected this project that Duarta already spoke about it last year, and that links very well history, engineer, and society, because the motivation for this was the studies that have been done, the research that has been done by CFTC about the historical gardens, and the collaboration with a multidisciplinary team, not only from Faculty of Sciences, but also from EST, that measured the energy produced by the hydraulic wheel and developed models to produce clean and low energy, and that are now being experimented and tested for wastewater management. And this is also done in cooperation with Águas de Portugal. So it's really important to show how science, how history can help us, how understanding the history can help us to find solutions for the present. And by giving this overview, I now pass into one of the things that our directive board has been very keen of doing it, which is giving incentives to research and the environment. As you know, last year we had in this session presented the results of the internal call, the first edition of the internal call for projects that was devoted to research projects. This year, we opened the second edition that was devoted to innovation. Unfortunately, we could not give you the results today as we would like, but we would like to say that we had 9 project applications. These 9 project applications represent 5 of our research units, and of these 9, 8 were considered eligible, which is good. And if there is anyone in the room that is propounding these projects, the second phase will start from 1 to 30. They will be invited to present a full proposal, and the results are expected to come out on December 23. And the good news is that we are going to open a new call for proposals, this time for research again, and we hope to open the call on January 24. Okay, so be prepared, build your teams. You know that this initiative is to promote not only the development of research projects in sciences, but especially to promote multidisciplinary research. So we need, and it will only be eligible projects that involve more than one research unit for more than one scientific area of sciences. And finally, I finish with the thing that I think most people are waiting for. So I call our director to deliver the prizes. And as you know, we have been investing a lot in recognizing to the whole community of sciences the merits of our researchers that are contributing to our excellent research. And since the last year, we not only selected the person that most contributed in the last year, and now I'm speaking about 2022 because the statistics are only done at the end of the year, but we also started last year to acknowledge the best, the person that produced more in each scientific area. So I'm going to call the persons that received the award this year. All the nominees know that they were selected because and I hope they are in the room. So I will start first by calling Inês Fragata. So Inês Fragata still did not win the prize of the best, the person that produced the best, the high number and the quality of papers, but she won the fundraising award. I'm sorry because I forgot that. And as you know, she was here last year because she won an IRC project grant. So naturally, the amount of money that she granted, she deserves this award. Thank you very much, Inês. I profit to say that with this IRC grant, together with another IRC grant that we won previously to Sara Magalhães, we were able to create a new infrastructure in experimental evolution that was planned to be inaugurated today. Unfortunately, we could not, but in January, we will have the official opening of this laboratory, and I invite you all to be present and to visit because it's really a major infrastructure of the faculty that deserves really to be recognized, and it is somehow unique in so far in Portugal. So I think, thank you very much, Inês. You want to say something? You want to say something? Okay, thank you very much. Now, you can, afterwards we will take a picture of all. But now, go into persentificar. Pode sentar, Inês. So starting by chemical sciences and technologies. So the award goes to Ms. Miguel Machuqueiro, which we call from the bioreason. For earth sciences, we call Ana Russo from IDEAL. From physical sciences engineer, we call Nuno Araújo. From mathematical sciences, for the second year in a row, we call James Kennedy. From GFM. And for computer science and engineer, Sara Madeira from LASIGE. And from history and philosophy of science, and again for the second year in a row, and Duarta Rodrigues from CFTC. Thank you very much. And as you know now, understand, the first prize goes to life sciences. Sorry, I'm happy. And the winner is Bernardo Duarta from MARE. So thank you all for making Ciências so excellent. And I will finish now and give the word to Bernardo, which is the first awardee. He has some time to explain or to convince us why we select the best person to do it. I just want to recall, because I forgot that the way these prizes are awarded is based on our information system for bibliographic. We use this criteria, which is not only the number of papers, it's also the quality of the paper. And only the people that enter the papers on the biblios are elected for the prize. So if you want to be here next year, please do so. So this is us. I hope I have given a little flavor of what we do in Ciências, which is very good. I will quote again LASIGE because so far I didn't got a better phrase. So we are really driven by excellence, and we hope to continue so. Thank you very much for your attention. And Bernardo. think you'll be glad to know. But we decided that this year, last year it was, every year we have a new thing to announce. And this year what we announced is that we decided to give some financial incentive to the first awardee. So Bernardo, you are going to win the fantastic amount of 5,000 euros for using in research.
So, good morning, everyone. So once again, thank you very much for this award. As our dean was telling us, nowadays we are always talking about artificial intelligence, and there are many apps available for that. And I decided to try to give to one of the ones that is available all that I want to wrap up in this presentation and see how it comes. And it results like this. So it might seem a little bit awkward, but this was generated by artificial intelligence, and you will see with the decor of the presentation that how it will make, I will try at least to make some sense of it. So, but in fact, what I'm coming here to talk about, and this is the most scientific title, let's say like that, is of environmental fingerprints. It's the most common guideline that I have to describe this last year. And so, in our planet, we have a wide variety. We harbor a wide variety of organisms, environments, ecosystems that have a strong gradient, not only in terms of physical sciences aspects, but also in climate, and that reveal to be also highly specific in some cases with more local variations. And these variations are even important if we look to our small part of our planet. Here, our coastal ecosystem of Portugal, including the islands. And this will leave some marks in the organisms, mostly due to the climatic conditions that vary along these gradients, but also the chemical environments that all these environments have. They are different, they subject the organisms to different conditions, and also the organisms will interact differently with the populations that surround them. So the populations are also different, so they lead to different biotic interactions. And of course, we have also to consider our human footprint. So we are also introducing some variation that is not natural, but will inevitably also lead to some changes in the organism's environmental fingerprints. And this is true, and now it will make a little bit more sense of the first slide. This is true either if you are a bacteria, a diatom, an apple, or a fish, or a human being. So everything will leave its mark in your organism, either if you are in one of these type of organisms or any other. So this is important to consider when evaluating and when analyzing how the organisms behave within its environment, but also we can use these environmental fingerprints, and that is what I'm going to speak here. So these environmental fingerprints will be more denoted either on a structural level, in the components of the cells of the organisms, or even on the functional level, so how the metabolic pathways are affected, and how in the end up it results in a metabolic network that results in the overall lifestyle of the organism. And this can be applied in several fields, and I'm bringing here only three fields that I can use an example for food sciences, for ecotoxicology, but also for biotechnology. So going to the food science, so we had a big project, it was called the MARE project, where we were proposed to develop biochemical markers of the origin of the seafood that arrives to our markets and to our houses every day. So basically we tried to analyze several organs of several organisms, in this case was seafood, but you will see that there is a translation of these techniques to other fields, but analyze different tissues about its components, either if they are its fatty acids components, its amino acids, its proteins, whatever, all the biochemical components of the organisms. We try to develop some pattern recognition analysis so that we understand how things vary, for example, along our coast, so that we can produce models that could pinpoint from where the fish came from. And this is important to fight food fraud, for example. And I bring you only 2 examples here. So we have, for example, a large fish like the skates that travel a lot along our coast, and that we try to use more than one type of marker, and you see that is, depending on the marker, we can have different efficiencies in predicting from where the fish came from. So different markers will have different accuracies, but also in the case of the production type of the fishes versus, for example, the wild captures of the fish, we can also use these markers to distinguish, for example, what is fished from what is produced in aquaculture, either in several ways of production. But we can translate this. So we developed the techniques for the fishes, but we translated it also to problems that are occurring not only in the fish market, but also, for example, in the fruit market. So we have, for example, maçã de alcobaça, that is a protected geographical indication denomination. So it has an increased value because of its characteristics, where it's produced, and that confers a higher market value to this type of apples. But sometimes on the markets there are introduced some products from apple products that are deliberately mislabeled so that their value increases, and this way they can achieve values that will be near the ones that maçã de alcobaça can achieve. And so we also try to translate what we learn from the sea to the apples, and it was possible to develop some models also to identify correctly with a very high accuracy if the apples, independently of their variety, came or not from the maçã de alcobaça IGP area. And this is very important because this ensures that the consumer can trust what he is eating and that he's paying really for IGP variety. But also we try to do it on the national level, comparing the varieties that come from the Alcobaça region with the same varieties come from other regions, for example, from the northern Portugal, and it's very easy to detect from where they come using the biomarkers that we developed previously. So we can see that the environmental fingerprints here can be used also to fight the food fraud. But also for ecotoxicology. So one of the things that we have been learning in the past years is that we have putting a high pressure into our oceans, and this led to several types of contamination, namely, for example, pharmaceutical contamination of the environment. So we dump a lot of pharmaceuticals in the environment, either deliberately or because we take them in excess. And they end up in our waters, but also in our organisms. And this has been widely studied for example, the fishes. But there was a small gap that we tried to fulfill. That was, how about the impact of these pharmaceutical compounds in non-target organisms, such as the phytoplankton. So they don't have the same animal receptors to which these pharmaceutical compounds were designed to act. And so we tried a metabolomic approach with our colleagues here at the faculty also, and we saw that several pathways were affected, for example, by antidepressants in marine diatoms. So although they don't have the same neuronal receptors that, for example, humans have, somehow the antidepressants end up affecting several metabolic pathways. And what we saw is that, in fact, there are a high number of conserved receptors in diatoms that could bind to these neuroactive compounds. And in the end, in fact, we have not antidepressed or more happy diatoms, but in fact we have depressed diatoms. So they grow less, they produce less oxygen, and that ends up impacting all the life on the planet, since they produce a high amount of oxygen for the whole planet. And then we also went a little deeper. So how does these pressures affect even smaller organisms? And we went to look for the hidden majority in our ocean. So the bacteria, the archaeas, so everything that normally is a little more neglected, but is basically the majority of the organisms that are within our ocean. So this resulted from probably the first and the biggest world's effort in sampling in simultaneously all the oceans of the world at the same time, in the same day, and sequencing all the diversity that was available in a drop of water, okay? And this was repeated for several years, and we tried to use this, some of the results, because it's an immense amount of results, some of the results to analyze how our footprint is leaving marks also in the bacteria and how we can use them to monitor the environment. And one of the things we notice is that although on taxonomic terms, they don't change that much with the pressures, but in functional terms, they change a lot. So we started to find what we call resistome profiles, which means that the bacteria developed resistance genes to several compounds, namely antibiotic, heavy metals, and others, in response to several conditions that were imposed. And this revealed to affect also several metabolic pathways that were able to be associated with different environments, for example, in our coast, and related with different pressure indicators that we had for all the sampling sites in our coast. And this allowed us to produce the first resistome analysis on a countrywide coast. So in this case, for Portugal, that was also one of the most sampled countries in this project. But if these bacteria can have these properties and they can develop some of these resistance genes and some specific genes, why don't we use them also in our favor? So we start to use also these bacteria for bioprospection. So we are looking for them, not only the ones that are in the water, but all marine systems, and try to isolate the ones that could be useful, for example, for agriculture, and to solve problems that we have nowadays due to climate change. And so we identified several bacteria, and this was the first assay. It was done in collaboration with the University of Seville. It was done basically in the kindergarten that is next to the University of Seville by the kids. So we supplied them with water supplemented with our bacteria, and they only had to water the spinach, the lettuce, the small production they have in the school for their learning, but also to feed the cantina. And the result was that the bacteria increased a lot the growth of the vegetables. And this was like a proof of concept. If a kid can do it, so everyone probably could do it. But we brought it to something that is most dear to us, and it's a problem here in Portugal that is, due to its high economic value, it's how to maintain our grape production for wine production in Portugal with climate change. So we tried to use these bacteria to improve the resistance of our grapevines, for example, to heat stress. And this is an example. If you look, this is an imaging analysis of the photochemical, in this case, the physiological status of the leaves. If we use some of these bacteria in the grapevines, we saw that some of the grapevines were able to completely maintain the conditions of the control, even if they are under a high heat stress, in this case, a heat wave, a very severe heat wave. So, in fact, these bacteria allowed the plants to cope with climate change, and they could be used as a nature-based solution to counteract the effects of climate change, for example, in the grapevine production in Portugal, as important as it is. Also, and wine is under production now. Let's hope to have the first wine with the taste of the ocean, probably. But during a year, we were supplementing some grapevines with this kind of bacteria, marine bacteria, and we've already found that the grapes are bigger, they are larger, they are sweeter. So we are now testing for the wine. Let's hope they produce good wine also, and to have the first wine with the taste of the ocean. But all of this was only possible because we have a very good network of collaborations, that some of them for several years, some more recent, that allowed us to gather expertise from several areas and help us to follow this path along the environmental fingerprints and how we can use them to overlook to our organisms. And also because within the last year, we have several collaborators that were either co-authors or they participate in the projects where this investigation results, and that allowed us to make this pathway and produce this very nice research line that produced these very good results. So, muito obrigado.
Thank you. Thank you, Professor Bernardo. And congratulations once again to all our awardees. It's now time for us to start our first session. It is time to act today for a better tomorrow. This session is focused on global challenges. Today we pay special attention, as was mentioned, to climate change, energy transition, and artificial intelligence. We are really fortunate and proud to have a strong research community on these topics here at Ciências. And remember the testimonies that I told you about in the beginning of today's ceremony? We have the first one to watch just now. Let's see from the beginning.
A minha principal atividade de investigação é em torno dos desastres naturais induzidos por grandes eventos extremos climáticos e meteorológicos, incluindo grandes tempestades, cheias, deslizamentos de terra e, particularmente nos últimos anos, em torno de fenómenos extremos que ocorrem no verão, secas, ondas de calor e incêndios florestais. Estamos particularmente preocupados porque alguns desses extremos climáticos têm vindo a ser amplificados em frequência e em amplitude no contexto das alterações climáticas. E é precisamente essa a principal razão pela qual o tipo de estudo que fazemos no nosso grupo é particularmente importante para a sociedade, porque, como se pode ver pelas notícias frequentes nos mídias, aparece com muita frequência os efeitos destes extremos. E nós temos grandes relações com a proteção civil, para as quais fornecemos ferramentas de diagnóstico e de previsão de alguns destes fenómenos extremos, mas também com algumas empresas privadas, como do grupo EDP e do grupo Navigator.
Thank you, Professor Ricardo. I don't know if he is in the room. Stay tuned for more testimonies throughout the day. And now let's welcome to the stage Professor Cristina Branquinho from the C3C Research Unit to share with us what she believes to be the power of nature under climate change. Here it is.
Good morning, everybody. So Bernardo helped me a lot on this title, so thank you very much. So I'm trying now to go to a different scale. So I would like to introduce you this forest here, which is the same forest for 180 million years. And it's located in Australia, and it's there for all this time. As well as, for example, the most known Amazonian forest, rainforest, that is there for 55 million years. So those ecosystems that are there, they are stable, they are resilient because they have self-regulating mechanisms that allow them to maintain their sustainability. And although they pass and they go from different phases, as you can see here on the right. In fact, ecosystems are subject to disturbances, and sometimes they really resist, so they don't change any of their characteristics. Sometimes they really change their characteristics momentaneously, but then they are able to go back to the same state, so they are resilient, okay? So this is really important when we are speaking about ecosystems. And moreover, in terms of ecosystems, besides they having the secret for sustainability and resilience, they also gives us a lot of goods, such as food and wood, that's common. But not so common is to think about this as a good is when we look to a landscape and feel very well, or when they help us to regulate the climate, regulate the ocean acidification, or, for example, regulate the hazards and extreme events that Ricardo Trigo was telling us about. Sorry, there was it here. So in terms of those disturbances, when we have those disturbances in ecosystems, normally if the ecosystem is healthy and it's in the same, in a very healthy situation, they cope with most of their disturbances. But in certain situations, they really need to change to a different state. So this is what happens in certain situations, such as we expect from climate change. So sometimes they change in a gradual way, like here. So we're increasing the temperature, for example, and we're decreasing the productivity of an ecosystem. But most of the times, they really have non-linear responses. So just a small amount of temperature will change completely the system and put it in a different state. Normally, that state is not so good and doesn't provide so many goods, so many ecosystem services and goods for the society. And sometimes we understand that, and then we want to go back. And sometimes ecosystems have what we call hysteresis. So even when we go back to the previous conditions, we don't get the same ecosystem. We have just when we really go back down to other points, we can get to the same level of the ecosystem. And in certain situations where we lose functions, we really are not able to go back. And we are not able to reconstruct ecosystems from the scratch. So we are worried about that. So ecosystems have been submitted to a lot of pressure because of the dominance of the human species. Here you have the growth of the human population. But it's not only the human population that is covering our Earth, is also their domestic animals and pets. Here you can see, for example, the amount of humans and domestic animals compared, for example, to the wild species that have been increasing over time. So we really dominate Earth. And because of that, we had a lot of changes occurring on Earth, such associated to this population increase. We have more emissions on carbon that increases the carbon dioxide in the atmosphere. We have more reactive nitrogen, and because of that, we have an increase in temperature that is affecting us, causing a lot of phenomena that a lot of people here at university study, such as ice loss, sea level rise, extreme events, droughts, wildfires, marine heat waves, ocean acidification, and so on. And what about the system itself where biodiversity is here? So there's also occurring what we call a land use change, because if you see here on the left, we can see that at least 1/3 of Earth is changed from land use. So the land use changed on 1/3 of the Earth. So it moved from forest to agriculture, or from agriculture to urban areas. And some of them were just once in yellow. Most of them occurred in multiple changes. So 1/3 of the Earth already changed substantially. But this is a change in the land use. Sometimes if we consider not only a change in the land use, but also a change on land management, for example, we still remain in a forest, but the forest is managed in a different way. For example, for production, you have a land use and land change management map, which is the one here on left, where you see only the green areas, which are the ones which are not altered by humans. All the other colors represent areas where the current land use, more on this pink, brownish color, and then areas where there's land management change, where you have more those light pink colors, meaning that 2/3 of the Earth are completely changed by humans. And we live on that area. We are living on most of those very changed areas. And this impacts a lot diversity. And so climate change, land use change, which are associated, impact diversity. And if we look at some two indicators, one over time, one in time, and another one in space, we can see this indicator, the Living Planet Index, which focuses on some populations and track them over time. We already found a decrease on 69% of the abundance of the organisms that are there. So there was a decline on almost 70% of the abundance. And if we look that in space, and we use another indicator, which is the Biodiversity Intactness Index, which represents the amount of change in relation to abundance, what was there before, we see that at least 58% of the land has at least a 10% decrease in abundance, and we live on the 71% of that biotically compromised areas. So we change really substantially Earth with this information, with this impact and with this growth and with this dominance. But not only in terms of abundance, not only in terms of the amount, and we also change it in terms of the quality. For example, I'm just quoting here biodiversity homogenization. So as we do some practices and some anthropogenic activities, we change really the earth, for example, by flattening all the lands and mixing up the soil, which constitutes different niches for biodiversity, taking the rocks from the ground, for planting genetic similar species everywhere in large areas. For example, having more nitrogen in the air, in the soil and water, which completely filters the biodiversity that it's possible to be in certain places, as well as climate change when we increase temperature. We are confining the species that we are able to be there. And for example, another problem is the spread of invasive species, which completely replace the ones that are there, homogenizing the environment. So we are getting a less diverse, with less amount and more similar earth. And in fact, when, so if we go to this cycle and we have like a feedback problem on this cycle, is that we have less biodiversity, less carbon sequestration, so less capacity to mitigate the climate change. We will have more emissions because we have more naked soil, so the stocks will be more exposed, so we'll have increase in climate change, and then we will, because of that, we will have less productivity, we have less diversity, and we will keep on increasing desertification and going on the cycle. So the cycle repeats themselves in a negative way, so we increase the problems of climate change together with the ones of biodiversity loss and together with the ones of land use change. So the idea here is to use the power of nature to at least slow global warming, which already happened. So on the last 10 years, 54% of natural systems absorbed CO2 during the last 10 years, which means like having a 50% discount when we go to a shop. So half of it was solved by the nature. We still have large stocks of carbon in the system, so it allows us to have those storage. The ocean still deals with the excess heat it has, and for example, the albedo still allows us to not be so hot as we could be. So nature allows to have a lot of mitigation, also allows adaptation, because nature offers certain situations, as when we have wetlands, dunes, coral reefs. For example, we reduce the risks of extreme events, and of course, with, for example, having vegetation, we also reduce the effects of floods, for example, fast floods, and because it infiltrates the water. So enhancing and restoring health ecosystems can help increase mitigation and resilience, and reduce some of the projected losses and damages. So it's very important that we put nature everywhere we can and restore nature, not only nature by itself, but also the functionality of it. But as we are in a highway to hell, we cannot only invest in nature alone. That will not be sufficient. We will still need to decarbonize the society, and I hope my colleague Miguel will deal with that in the next talk. And at the Faculty of Sciences, we are dealing to most of the subjects that I spoke there before. So we try to understand natural fluctuations on ecosystems, especially in areas with low human impact, such as in Antarctica, for example, but also in other places where we have more human impact. And on those places, we try to evaluate ecosystem services, especially in urban and rural areas, to accommodate, to maximize, for example, regulation ones, to really increase the resilience of the system. We study ecosystem resilience and also their process over time using, for example, techniques such as space for time approaches, so that we try to understand where are the tipping points in the present and in future scenarios, so that we understand where we are close and try to mitigate those effects. We also use different facets of biodiversity and test different ecological indicators to understand the impact of human activities over time and to track them and understand exactly where and how they have been impacted. And we propose solutions for avoiding, mitigating, or restoring biodiversity in those areas that are needed. Of course, this is done with lots of data and with lots of processing data, which is also important when we're using different techniques. And last but not the least, I would like to show this photograph that represents the power of nature after a storm in São João da Caparica. Those are the roots of a Amalfilaria, which was able to deal with that storm and not affected the restaurants and bars afterwards. Thank you very much.
Thank you, Professor Cristina. And energy transition is surely a very present challenge in the mind of both scientists and non-scientists. But how can we have a clean and just energy transition? Let's now find out with Professor Miguel Centeno Brito from IDL. And let me put your presentation here. Here it is.
Hello, good morning. So, of course, in this highway to hell, I'd like to start by calling your attention to the very top right corner. I've been told that with present situation, I should always alert the people that I'm very realistic, which means that, of course, things are going to get much better very soon. I'll be talking a little bit about the energy transition today, and I'll move back because there's some feedback loop there. I'll start to say that, of course, energy is by far the most relevant culprit of climate change. So the first thing that we need to do now is to decarbonize energy, and I mean electricity, but also mobility and other uses of energy. So that's what I'll be talking about. And I'll start with this plot, which really complicated and you can't see, but doesn't really matter. This is from maybe May or June, I can't remember, recent review of over 100 papers that describe or model the world's energy consumption and generation by doing it 100% with renewable energy. And so the first thing I'd like to point out is that although newspapers, they talk about all these difficulties in getting away with the variability of the renewable resources, for a long time that we know that it is possible. And the other thing I'd like to point out is that there is a huge diversity of solutions. Different axes is the PV penetration and the wind penetration. And there's solutions for all tastes. And so, of course, it can be done. If you're not convinced, you don't have to work in energy modeling. You can just buy one of these two books. One is a bit older, the other one is from this year, and this just shows how easy it is to get the energy transition very done quickly. And if you look at examples, for example, Ecuador, 10 years ago it was 90% fossil fuel. Today, well, a couple of years ago, was already 90% renewable. And this is done because the Minister of Energy or something was an astronomer, and so worried about, like this, worried about climate change. But actually what was clear is that that energy transition brings you much lower costs. The energy bills in Ecuador are about 4% cheaper than they used to be 10 years ago. And when there was the invasion of Ukraine, our prices went much higher, and their prices stayed exactly at the same because they don't depend on gas from Russia. And there was some other secondary effects, such as being able to breed, which are also very useful. And this is just a paragraph to let you know that you should not be too worried. Anyway, there's quite a few challenges to overcome, and I'll talk about a few today. So the first one is, especially to make the connection to Cristina's presentation, and actually I just realized also with Bernardo, is trying to combine farming with solar generation. And I'll start with this project, which is our small playground here, just opposite. You can see C8 in the back, so probably you've seen this little farm, where we're combining solar energy generation and farming. And of course, we do it for many other reasons, but when you put the two together, the first motivation was, of course, to avoid competition for land use between the to avoid competition for the land use. But when you put the two together, actually the PV works, the solar energy generation works better because there is less dust and the temperature is cooler, so the panels are more efficient. And also we have less light or heat stress in the plants, and so they grow healthier. And also they use less water, which is often a problem as well. And I was just thinking about this project that I don't have anything to do about, but they're doing it in Ajuda in Isa, where they're going to build these solar panels on the top of the grape wine cultures. And so they are going to have an alternative approach to the marine bacteria to allow the grapes to survive with extreme heat. This is just to show that we're doing some science, but I'll just move on. Another way, another problem that we really need to solve is this, or actually two problems at the same time. The first one is how to match demand and supply, because solar generation happens when there is sun, and you've heard probably that there's very little sun at night. And the wind keeps changing a lot as well, and the demand happens when people want. And to be able to do that, you have to do it with storage, which usually involves hydro pump in big dams, which is a very good solution, but only in the places where it can be done. And the alternative is storage in batteries. There's plenty of reasons why you should avoid using batteries, including cost and critical materials and also toxic materials. And so, well, if we have to decarbonize mobility, which typically means replacing our dirty cars by electric cars, so maybe we can join the two together, because the batteries are there already, so we can use them. And charging cars is very complicated for the grid point of view, because people like to do it at very, very high power, very fast. They don't like to wait. And there's this really nice solution called the battery swapping concept, which is instead of you going there and plug your electric vehicle and wait for 20 minutes, if you're in a very high power place, or 3 hours if you're doing it at home, perhaps what you can do is you go to the service station and you drop your empty battery and you put a new one. And the people in the service station, they have the batteries for the day, and so they can wait until there is a lot of solar energy, so very cheap energy, and then charge the battery. So it's a very good business model for the people at the service station. It's very convenient for the users, and it's very useful for the grid, because you can actually match supply and demand with variable resource. This is just to show that it's really good solution. And if you want to know more about that, perhaps you can come here on the 24th of November at 6 p.m., where António Valera, which is a professor of this house, is going to be launching his book called The Transition: Why You Need Battery Swapping for the Future Energy System. There'll be a lottery to get a couple of books, so you should really come. Talking about mobility, we can perhaps accelerate the takeoff of solar electric cars if we don't have to wait for the infrastructure to be built. You didn't, because you were here, and there was no coffee break, so there's no chance you can see. But today there was the announcement that there's going to be building 24,000 new charging points in Portugal up to 2030, which is, of course, very welcoming if you want to transition to electric mobility. But there's perhaps some worries when you're buying an electric car that it's going to be complicated to find a place to charge it. Of course, you can do it here in the faculty, so you can just go to the C6 building and do it almost for free. But one very good option would be to get the generation of the electricity right in the car. And so we've been looking at it for a couple of years now. And worldwide, we are looking at an average of 20 kilometers per day if you get some solar panels on the top of your car. So the car looks the same and works exactly the same way, except that instead of going to the plug-in charger, you can just park the car or drive the car. So you do it anyway. Of course, there's going to be a decrease in CO2 emissions because you're avoiding consuming dirty electricity or partially dirty electricity from the grid. And the most important thing is that even if it's not all of your range that you do every day, especially in the winter, perhaps you can only charge, instead of being once a week, you can charge it every 2 weeks. And so you only need half of the charging points, or the same charging points can support double the cars. So very good solution. If you want to know more about that, you can go to that site where we're running this citizen science campaign, and you'll be able to track how much solar energy is getting to your car. The perhaps last example, maybe not, I would like to talk about is the data management that is involved in energy transition. Is that one of the things that it's not the last example, I forgot. One of the differences between the current energy paradigm and the old fossil one is that instead of having these big power plants, could be nuclear, coal, natural gas, or even solar, the most resilient approach, and actually the cheapest and preferred for everyone, is distributed system, where you get solar panels on everybody's rooftops. And then suddenly it becomes really complicated to manage all the data, because I'm generating, the data and the electrons, because I'm generating the electrons on my rooftop, and then I'll use some, and then I have to share them with my neighbor. But sometimes I don't have enough electrons to share, so I need to get from them. And so this collaborative approach is very useful, actually critical for the energy transition. And this is just an example of, imagine that you live in a community like most of us, and then we have a common rooftop that is generating electricity, which is producing during the day with a standard profile. And then you need to talk to each other. Actually, our washing machines need to talk to each other to make sure they are going to be using the solar energy instead of trying to use natural gas, expensive electricity late in the evening. That's the usual way that we do, is we come home and switch on our appliances. But if they could talk to each other and then make the best use of the renewable energy. Of course, this involves a lot of talking between the washing machines, and we working with that. And then, of course, I'm not explaining, but Cátia just next will be explain how washing machines can talk to each other. And then finally, coming back to the first plot, you remember I showed you there was 100 or more than 100 models. And one thing that I didn't call your attention is to say that they all actually good models. And so when we talk about the energy transition, it's not the fact that it's all distributed and all these different resources. It means that there is not one optimal solution, but there are thousands or even more solutions that are very cheap, much cheaper than today's energy. So of course we need to change to that. But they have different impacts, and the impacts can be tech labs, we need to remove the building and there's going to be no more innovation in the faculty. If we are going to do it somewhere else where there's very few people, we'll say, well, there's less social impact, but perhaps there's going to be, for example, impacts on biodiversity. And there's many different aspects. So this is a very multidisciplinary, or actually interdisciplinary business. And I'll just wanted to show you this, or tell you about this project that we're doing for Portugal, where we're modeling the 100% decarbonized country. And we have completely different solutions. Of course, you can't see because it's too small, but you can see from the pie charts that the green is wind and the yellow is solar and the rest doesn't matter. And you can see that you can achieve decarbonizing with optimal cost, that means very cheap energy, with completely different solutions. And these solutions are not different because they have more wind or more solar, so it's a different energy mix, but also because they're located in different places. Of course, you know that there are places that are more windy than others, and different seasons are more windy than others. And so you have all of these solutions, and then you need to try to decide how you can, what is the best solution. And of course, the best solution is the best solution for the people, because the cost is the same and the decarbonization is the same. And so what you have to do is to be able to involve the people in the co-design of the energy system. And at what cost? And now I'm talking about cost, not only cost in euros, but also, of course, all the different impacts, social, economic, and environment. And so we come to the last slide, just to remind you that renewable energy technologies are the cheapest, and of course, transition is going to happen. The question is the pace. Is it going to be by 2025, or maybe 30, or maybe 40? It will, of course, depend in different countries. Portugal is going to be much faster because we have much better resource than some, and a lot of money as well, and unlike other places on Earth. And then talking about some of the challenges, we have the big challenge of flexibility. Now you know there are many solutions. I didn't show anything about, but of course you need to worry about the critical materials. Basically, we are moving from this extraction of fossil to extraction of critical materials. And so you need to do it in a very clever way, for example, with very strong incentives to recycling, but for sure we'll have to increase the supply. And then the final message is that this cannot be done against the people, but we'll have to do it together with the people, and the people is all of us. And so coming to the very last slide, I'd just like to thank you and all these people that helped me, or been helping me in the last couple of years. Thank you.
Thank you, Professor Miguel. And we have all heard about the rise of artificial intelligence. Is this a challenge? Is this an opportunity to learn more about how it can empower science and perhaps help washing machines talk to each other? We now welcome to stage Professor Cátia Pesquita from the research unit LASIGE. Let me put your presentation here. Here it is.
Thank you, Marta. I need to begin my presentation with 3 disclaimers after the 3 wonderful previous presentations by Bernardo, Cristina, and Miguel. That first, no artificial intelligence system was used to produce any of the content in my slides, so no ChatGPT, no DALL-E, all human-made. Second, I am also, like Miguel, an optimist, and you will see this in my presentation. And third, my washing machine is actually smart. It's a new one. It sends me text messages when it's done cleaning the dishes, but it doesn't really put them away in the cupboard, so we're still far away from artificial general intelligence helping me with my household chores. But it's true that artificial intelligence is changing the way that humans interact with each other, interact with machines, and it is also permeating nearly every aspect of human endeavors. and science is not an exception. I don't think that I need to convince you that artificial intelligence is here to stay and it will have an impact in the way that we do science. So as we move from empirical evidence and scientific theory being the basis of classical sciences into a more computational and data-intensive world, my vision, and the vision that is shared by many at LASIGE and the Department of Informatics, is that we are now beyond the fourth paradigm in science. We are now not in data-intensive scientific discovery, but in knowledge-intensive scientific discovery. And it is my belief that artificial intelligence is a key aspect of this transition. But at Ciências, we are concerned with doing research in computer science and in artificial intelligence and its potential for synergies with other aspects of science and especially in the natural sciences. But as many of you have seen here in previous presentations, it's already there. Bernardo showed you uses of machine learning to detect the origins of fishes. Miguel showed you the uses of machine learning to optimize energy consumption. But in LASIGE and in our department, we are worried about what are actually the challenges in using artificial intelligence for scientific advancement and scientific research. And today I'm going to tell you about 3 major challenges in using AI in natural sciences. And I'm going to tell you a small story, a small vignette about how we are addressing each of these challenges. These are just small examples. There are many, many more. There are many projects, a lot of research. Actually, you saw my colleague, Sara Madeira, receive an award earlier, and she's doing research in this area. So it's a very active area of research. Although artificial intelligence has been in the headlines for the last year, we have been doing research in this area for a long time. And the way that we are thinking about this synergy between AI and natural sciences is structured along tackling these 3 different challenges. First, that science is producing, and ever increasingly, larger amounts of data that are in non-standard formats, that are heterogeneous, that need to be integrated. As science becomes more and more collaborative, multidisciplinary, systemic, we have this challenge of how to integrate data at large. Then also, there's the complexity of the data itself, but also of the natural phenomena that it's trying to capture. Whenever we describe the natural world in a data way or a computational way, we are always sacrificing something in that representation. So thinking about how artificial intelligence can help us sacrifice that complexity in the least amount possible is also key in this addressing this challenge. And finally, the lack of explainability. The root of science is scientists want to understand how the world, the universe, and ourselves work, understanding the why. And many of the advancements that have been in the news in artificial intelligence, they are what we call a black box. They are not explainable. And using black box algorithms prevents scientists that use them from really understanding how they work and using them to help us scientists understand natural phenomena. So the first challenge, large and heterogeneous data. So here I bring you this challenge of trying to integrate data from the micro scale to the macro scale, from the molecular up to the environmental. And we saw today in Cristina's presentation how this is key to address the challenges of climate change, to be able to have this integrated vision of the natural world. And to do so, for scientific data, this means we need to integrate perhaps hundreds of huge files that cover diverse types of data from different sources. We're talking about genetics data, phenotype, environment, molecular, images, text, etc. And one of the questions, one of the mini vignettes that I bring you here is this ability to integrate data from the molecular scale up to the environmental scale in one specific project. In this project, our driving question is, can we help oncologists in prescribing the right drug for renal cancer patients? And what we, sorry, it jumped. So what we have been doing in this European funded project is building two components, a knowledge graph, which I will explain in a little bit, and a series of explainable artificial intelligence predictors that will allow oncologists not only to figure out what is the best drug for a given patient, because the challenge is there is so much data now about a patient. You have the genome, the symptoms, the phenotypes, reactions to other treatments. And so in making a big picture out of all this data, to first have the drug recommendation, but also addressing a really important problem here, which is how to promote trust. So the oncologist will not prescribe the drug if they do not understand why that drug makes sense for that patient. So in this project, we are building a knowledge graph, which is a very large data structure that combines knowledge and data, that contextualizes and integrates all of this data, and also the artificial intelligence drug recommendations. And by having all of these data, and here we have a very small example, so, but in reality, this graph is tens of billions of nodes, okay? And by doing this, we are not only empowering the algorithms with the knowledge behind the data, so the description of what a molecule is, what a drug is, what an enzyme is, what is a molecular relation of inhibition between a drug and a given enzyme, but we are also capitalizing on that to figure out a way to explain to oncologists why that drug makes sense for a patient. In this case, we have a patient, anonymized here, John Doe, and we can explain the AI black box recommendation of giving the patient the drug sunitinib because we can explain the molecular mechanism that makes sense with that recommendation. In challenge 2, we are focusing on data and phenomena complexity. And here I bring you another important question. Can we support a timely administration of non-invasive ventilation in ALS patients? And here I must say that the PI at LASIGE is my colleague Sara Madeira, which you saw earlier today. And here what we're doing in the Brain Teaser project, which is also a European funded project, is to use AI to support patients that have neurodegenerative diseases, amyotrophic lateral sclerosis, and multiple sclerosis, and their clinicians. So what we want to do in this project is to have predictive approaches that leverage artificial intelligence to improve the quality of care for these patients. And to do all of this based on an open science paradigm to make scientific research and its outputs available to the community without compromising patient data confidentiality. And one of the examples that Brain Teaser has achieved is a case study in predicting the need for ventilation for ALS patients. And in here, the challenge was to handle the complexity of all of the data that was collected by these projects and projects before it that combines symptoms data, evaluation scales data, genomics data on the patient. And all of these data along with the time dimension, because these are diseases that progress. So this was a challenge, how to capture all of the complexity of this data and of the disease phenomena to try to help clinicians anticipate the need for ventilation and provide a timely recommendation for ventilation for these patients. And by combining advanced clustering techniques and a classifier, the researchers at Brain Teaser were able to predict the need for non-invasive ventilation with between 70 and 80% accuracy, which represents up to 15% improvement than previous approaches. And the final challenge, explaining scientific artificial intelligence predictions, is actually a smaller project. This is not EU funded. This is more of a grassroots movement. It's about the topic of a PhD student and a very recent collaboration. And the question was, can we help biologists understand the mechanisms behind predicted protein-protein interactions? And so, together with my PhD student and my colleague Sara Silva, we developed a way to explain the relations between proteins that are described in these huge knowledge graphs that describe how data and science, and scientific knowledge is connected. And we developed this algorithm that is both able to predict protein-protein interactions with high accuracy, over 90%, but is also able to produce mechanistic explanations that could hypothesize how those interactions are supported by the proteins. And one of the interesting things is that this algorithm is able to find what are the most relevant aspects, and in this case, functional aspects that the proteins share, and build them to use high-quality explanations. And now, the Easter egg in my presentation, something that happened this week, just to finish very quickly, a few months ago, I gave a presentation at an event at the crossroads between biology, maths, and computer science. And I talked about this. We have an algorithm that predicts protein-protein interactions, and it works really well. And Carla from BioEasy approached us and said, how would you like us to test those proteins in the lab, you know, some of your predictions, and see if we find a new, a novel, an unknown, but predicted by your algorithm interaction. And that's exactly what they did. And out of 5 proteins that they tried, 3, I can't explain you the details, okay? It's been a long time since I was in the lab. 3, the experiment didn't really work, but for 2 of them, it works. 1 was inconclusive, and the other one is this one. So it's an interaction between these 2 proteins, one protein that has a crucial role in inflammation in respiratory infections, including COVID, and another one that plays a role in the way that natural killer cells, dyneins that move things across in the cells, work. And what you see in that chart is the explanation of the interaction. It tells you what are the relevant functional aspects that the 2 proteins share that are important to support that prediction. So to finish, I believe that artificial intelligence will be the key that scientists will turn to unlock our understanding of the world, the universe, and ourselves. It will be no surprise if I tell you that I believe that artificial intelligence will become a core skill of the scientist of the future. So to finish, I would like to thank also my scientists of the future, my past and present students, and also my collaborators. Thank you very much.
Thank you, Professor Cátia. And let me switch here the presentation. Just a few technical seconds, because it was closed. And now it is time for what we are waiting for, which is the coffee break. Before I announce the coffee break and you all leave for the C3 atrium, I would like to tell you that our 3 plenary speakers, as well as the previous speakers, will be available if you have any questions, so please interact with them. And we meet again, let me check the time. We can meet at 12:05, okay, because we are a little bit behind schedule, so 20 minutes for the coffee break. And you can also nurture your brain by viewing the poster session that is taking place at the atrium. So noon 05. Thank you very much. Welcome back, everyone. I hope you had a pleasant coffee break. It's time to start again our sessions here, the plenary sessions. And do you remember the global challenges we have just discussed before the coffee break and the testimonies that I told you about? Let's see another one. Let's hope we have sound. Let me just check upstairs if we do have sound.
A minha investigação em mobilidade sustentável está dividida essencialmente em 2 vertentes. Por um lado, na vertente da análise da viabilidade ambiental e técnico-económica de biocombustíveis, essencialmente para transportes coletivos e de transporte de mercadorias, e sempre numa lógica de biorefinaria em substituição da refinaria tradicional de petróleo. ou seja, produzir biocombustíveis e, simultaneamente, outros coprodutos de valor para a sociedade. Por outro lado, a minha investigação está direcionada ao estudo de métricas, indicadores, que permitam comparar instituições de ensino superior em termos dos seus movimentos pendulares, quer dos alunos, quer dos professores, quer dos funcionários não docentes, comparar numa lógica nacional e também internacional e perceber onde é que se pode melhorar, onde é que se pode mitigar as emissões de CO2 e diminuir a pegada carbónica destas instituições de ensino superior. Neste sentido, digamos, a mais-valia para a sociedade, para além de estarmos a formar alunos nesta lógica, é de facto conseguir reduzir as emissões que são muito grandes a estes níveis.
Thank you, Professor Carla. Okay, thank you. So many aspects for us to think about. Unfortunately, so many researchers here working on these aspects at Ciências. And we now start our second session on science fundamentals. We will have a slight change in the program. We will start with physics and asking ourselves, what is wet artificial life? And we will learn about that with Professor Margarida Telo de Gama from CFTC, whom I now call to stage, please. Here it is. Here you have.
Okay, thank you very much for the invitation, and thank you for this slight change in the order. And thank you for all of you who are still here. This is lunchtime, this is not coffee break. Anyway, yes, the title has been a little bit provocative, but it's not just my own choice. So this is a more realistic title, From Soft Matter to Wet Artificial Life. And I think I have done soft matter all my life. So I know something about the physics of soft matter, and the A-life came almost by accident. So I am a physicist, and it's not that I don't care about solving all these challenges and so on, but most of my science was just driven by curiosity. And I was sufficiently lucky to be funded and to have people wanted to join me in that endeavor. So basically, I think this is the first message, and the second one, you might find it a little bit, oops, I want to go back. This is there are no logos on that page. I really cannot use the laser because my fingers are too big. Okay, you see ULisboa, and the reason is I'm in Ciências, and I've always been in Ciências, and but I think, and this is the Ciências Research Day, but somehow I feel part of a bigger community, which used to be UL, it's now ULisboa. It's like in Cambridge or in some other places. I'm not saying I'm from faculty or college, such and such. And this is something which is maybe a bit strange. It doesn't mean to provoke or anything. It's just something I feel quite deeply about. Okay, so let's start with artificial life. So I'm not going to say very much, but I'm going to say there is a distinction between ordinary matter and living matter, and I am a condensed matter physicist, so I've been working most of my life, or my life basically, on condensed matter systems of inanimate or non-living matter, okay? So this is just something I took from a publication. I'll show you the reference to that publication later on, and it's certainly something nobody can argue with, you know? This life is different from... So let's go now into artificial life, and then, you know, there are three kinds, and two of which go by the name of soft artificial intelligence. We've heard about it already in the previous talks, not in this particular context, but related to it. And then there is the other one, which is the hard, which is the robotics and the robots. And then there is the wet, which is probably, I don't know, probably less well known, and it belongs to a field which maybe it's in biochemistry or whatever. But I'll be interested in wet A life from a physicist perspective. So I'm not really, yes, I have not really changed fields. I'm still a physicist. Okay, and all of these came, and the idea, not of the work, but of framing it in this respect, came from a publication of the EPS, the Europhysics News, last December in 22, had a number dedicated to the great challenges of physics for the 21st century. And this is a preview of a book which is being written, and each chapter in the book addresses a particular challenge from the physics point of view. And one of them is living systems, and in fact, to be more precise, let's see if I don't change the slide. Physics for understanding life. So I'm already a little bit away from the sexy title, but the sexy title attracts at least journalists and so on. So this is the outline of the talk. Oh no, maybe I'll go back a little bit. Maybe it's I'm going too fast. I really. Where do I have a watch here? I don't. No, I have one, but I thought I had it on the computer. Okay, I don't know what time I started. So this is okay. So this is from that article, and it's because I cannot stand. I really cannot. No, but tell you something new. Okay, that's from that article, and it's about wet A life in a way, and let me try and get the laser. So this is life as we know it, and it's in green, it's nice, and it has chemotaxis and some shape changes or appendages in living organisms, and then it has multicellular organisms or even social behavior. And then this is an analogy that is made from droplets. Droplets is the key word of the talk, and this is something I'm going to really focus on and something I really know something about. So these droplets are not normal water droplets. They are droplets made of active fluids. And so I will tell you a little bit about active matter. And then, of course, these droplets have some behavior that resembles some of these living-like, oh no, this is real living behavior, and this is life as it could be, life as we know it. But really the talk is about droplets and droplets of active matter. And someone should take track of the time. Just tell me 2 minutes before I should stop. Okay. Okay, so this is the outline, and let me dive quickly into active matter. Active matter is a type of matter which it's out of equilibrium, so the particles that make the condensed or the extensed phases of this matter, they take energy from the environment and they convert it into work or some other life-sustaining activities. But I think this is one of my favorite topics in physics. You know, it happens at a wide range of length scales. So you can have it at the you can have it, where is it? At the nanoscale, where we have the biomolecules, and we'll hear a little bit more about it. Then we have bacteria and artificial micrometer-sized particles, and so on and so forth, and you get to the big birds or even animals, okay? And now this is the particles, the building blocks. And the things we're interested in physics is how on earth, when you put them together, what sort of emergent behavior do you get? This is not about intelligence, just dynamical or even structural behavior. And so I jump to this part C, and you can see that, you know, sometimes they cluster, sometimes they move in flocks, sometimes they swirl around, and so on. So these are behaviors of active particles or systems of active particles that you don't see in passive ordinary matter. So as a physicist, I'm interested in that, and I could be interested in the other one, but I don't have time to go through it. So it's another interesting topic. So here are some examples. This is actually very famous because these are starlings, and in Roma they do all sorts of you know, wild types of swirls and flocks, and this has been actually measured using very high-tech machines from the top of the Termini station, if you know Roma. And now this is on another scale, bacteria, and on a tiny, the smallest scale, these microtubules, which are molecules, or at least they are biomolecules, okay? And so, let's see, I hate these things. I want to focus more on this lower scale because this is the type of system I have in mind when I show you some results. And so basically, they made of the microtubules, which by themselves are not active, but then they have these kinesin motors, which attach to them, and they make the move, slide sort of through each other. And these are some experiments. I mean, this system was invented. It was clearly synthesized, and many of the results in active matter dynamics, etc., they really can be controlled in this particular system. So it's a wonderful system. I'll mention, this is from this person's lab. He was at Brandeis at the time. He's now in California, at University of California. And so he does just regular physics or engineering experiments. This is just a velocity field, and the arrows are just taken by these methods which are well known in hydrodynamics, and the same here, so tracer particles. So you can analyze and measure these dynamics, which is very different from what happens in passive systems, and you can modify it because you control the building blocks. Actually, Dogic made these blocks himself, so it's a sort of dream. Okay, this system became so important that it made the cover of Science not too many years ago. And physicists went wild about it in other ways because this is a system, and I'm going to use some jargon, I'm sorry. It's a system which is globally disordered, locally ordered, and the disorder comes about because there are defects in disordered systems. You can see the defects here. And physicists love defects in topology, and in defects in topology are mathematical branches which are very popular. And so this is one of the reasons why physicists became interested in studying this system, on which, don't forget, we have experimental control. So we can really study it. And so how do we study these systems? We have basically two different tools. These are actually pictures from the same lab in Brandeis by a theoretician. And we have two different types of approaches. We can take particles, and we make one of these particles self-propelling, and the other species non-propelling, and these are sort of represented here, and you can just run a simulation, a molecular dynamics or something, particle-based simulation, and you see that there are structures and motions. These are still pictures, so you don't see the motion. But you can see some arrangements you don't see in the passive analogs, okay? But there is another way to look at these, and for that it's crucial that we have such the particles are at the microscopic level. So we have the field approach. The field approach is what I showed you before, that in hydrodynamics is the first field theory in physics, no matter what the field theories say. So it's the oldest, and it's the first, and it's still kicking, you know, and it's giving lots of new results, especially for these active systems. And so what can you do in hydrodynamics? You smear out the density, and you just treat the fields, which are the velocity fields and so on. So here I have some velocity fields, I think, because, yes. So the green and the blue are just represent here. This really means that this system is self-flowing. It sets itself in motion. And here it's a correlation with the order, with the, in this case it's nematic order, it's the order that you have on the liquid crystal displays that you have in your computers and so on. Okay, so far for the introduction. I have this, I hate these. Okay, why did I choose to speak about this? Because this was something we were working on, not about A-Life, but about these active systems. And we were writing the paper when that news or EPN news article appeared, and it sort of, it all made sense to sort of link it together. And I would like to say something about this This is just about one result for a single paper. The paper was, it took forever, but anyway, this is a master's student from engineering physics. And that was, oh God. And this is Rodrigo Coelho, who really is the expert on very sophisticated computational fluid dynamics techniques that you need to treat these systems, okay? So this is actually from the article. It's now published, and let me go on. Okay, so the first thing about these systems is that if you put a droplet of these fluids on a surface, it can spread, not due to the intermolecular interactions, but due to these active forces. And these forces that generate the currents can also make these systems spread. So there is an example right here on the top. This is just deformation. Doesn't really matter. Forget the second. And why am I obsessed with this type of result? Well, first of all, I've worked on wetting for most of my life and wetting transitions, but also there are some nice experiments. Okay, this is just some how we saw it was driven by the activity, which is the intensity of those active nutrients. And this is two lovely experiments. One on, this is actually the system I was telling you about right here. And you see, this is a wild system. This is just a test tube, and the interface goes really wildly. I mean, fluctuates on a scale which you don't see in passive systems. And then this is the type of wetting transition that I was talking about. And there is a characteristic of this transition, which is that it depends on the size of the droplet. This is not true in passive systems. But also, this was actually introduced earlier by a group in France and Spain, and this is now a tissue. These are epithelial tissues, and this has been measured and modeled, again, using similar field theoretic approaches. Okay, so what did we do? So I didn't say here, this surface, these things have some local order, and the surface aligns them parallel to itself. And so you get names for these. It doesn't really matter now, but and then you get the real zoo if you go to the different type of anchoring, which is now homeotropic. Now these molecules like to stick out perpendicular to the surface, and then you get, you know, this is a global diagram where you have activity, which is the strength it's tell. So if this is 0, this is just a passive system, and this is the contact angle, good old young contact angle, force balance, blah, 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 in the passive case. And you see a range of behaviors which is very, very rich, and some of which we understand, some of it which we still need to understand a bit better. And I think this is better if I do it this way. So this is the first regime. If we have a droplet and the activity is small, then it just sits still. But then at a certain activity, it breaks this symmetry and it starts walking. It can walk to the right or to the left, it has no politics. And this is correlated with the defects and the way the defects move. And this is not very exciting or sexy or whatever, but self-propelling is actually some of the things you can get from the environment. You get the energy and you make these things move in a way which is directed. It's not random. I think I like to use my fingers. And now, let's see. We have lots of non-steady states. 2 minutes. I'm almost finished because this is at a higher activity. The droplet actually becomes turbulent, which is to be expected. And again, this is some analysis of the order and the defects. And before it becomes turbulent, it has this nice, cute, very quasi-periodic dynamics, which is something that most of the time the transition to turbulence is too quick and you don't see the intermediate non-steady regimes. Oh, here they are. And we don't understand them completely, and but that's it. This is just some the droplets, the flow field, because these fluids are flowing, and this is just the order, the orientational defects and the order in the droplets. So we can analyze that in great detail, and I'm not going to show you the other regimes except that it can actually break, the droplets can break, they can detach from the surface, and I'm not going to play the videos, and they look very wild, and oh God, but if I want to... Finally, for large droplets, I told you this is something that is very different from the passive case. For large droplets, the behavior is totally different, and I'm not even going to comment, but I'm just going to show you two things for large droplets, and they do look very different from what I showed you before. For activities, this one is fairly strong. Okay, so I want to finish, and there are some some messages, but basically we started this really driven by curiosity, and then there was some big physics question in related to this artificial wet life, and so we decided to take it in that direction, but I still don't know if this is wet life. It depends who I speak to, and to be honest, I was interested in the physics. There are many, many different problems. So I'm finished. This is just for Luís. Luís Correia told me I could not give a talk here without equations, so here are the equations. I think they really horribly, you know, I mean, I can talk to you about them, but they really are horrible and non-linear, difficult, but Rodrigues is quite a genius, and he solved them in the computer, computational fluid dynamics. Thank you very much. I'm sorry if I went too...
So, thank you. We will now switch to mathematics. I welcome to the stage Professor Bruno Loff from LASIGE and CMAFcIO, our last ERC awardee from the European Research Council, and according to whom mathematics is Sudoku. So let's learn why. Let me put your presentation here. Here it is.
Okay, so there are several ways of giving a talk, and you'll realize that mine will be a bit different. So I'm not very good at doing these like broad talks, and then we did this and this. So I kind of like to invite you to sit by my fireplace, and I will tell you something which will hopefully trigger your mind a little bit. So I'm guessing most people here have learned some mathematics, and I'd like to make the preposterous thesis that mathematics is actually Sudoku. I hope you know Sudoku. It was popular, more popular maybe 10 years ago than it is now. So this is a Sudoku puzzle, and the idea is that you have to fill in the missing entries in such a way that there's no repeated numbers. So you can use numbers from 1 to 9. And there can be no repeated numbers in any row or in any column or in any block of 3 by 3. And that's it. And that's your task. It's a puzzle. It was popular. You can buy Sudoku books to practice. And once you start playing around with them, you realize that there starts to be some kind of logic, as the fact that these numbers are here implies somehow that I cannot put a number, such and such number here, and that in turn, together with this other one, implies that I must put a 5 there. Stuff like that. Okay, so it's a fun game to play around, and I did my fair share of Sudoku. And I would like to actually claim that all mathematics is Sudoku. Before I can kind of defend this claim, I'll have to try and say something about what is mathematics, right? Otherwise, okay. So I would like to say that mathematics is the branch of human knowledge that studies that minuscule part of human experience that can be described and talked about with complete rigor and precision. The mathematical objects are those concepts that can be precisely defined using language. Mathematics is the study of mathematical objects using that part of language which lacks any ambiguity. And I'd like here to make a distinction between what I'm trying to come to, which is some kind of broad definition of mathematics, and the actual practice of mathematics, which is itself quite different. So let me give you some examples of mathematical objects. We all know a few. There's numbers, there's functions, there's geometric objects, algebraic objects, combinatorial objects, or for example, something more connected with physics could be a mathematical model of an atom, and so on. And of course, there's also non-mathematical concepts, such as love, justice, health, or even the concept of an atom, which is itself not mathematical, although the various different models of an atom that we may have in mind are themselves mathematical. So you see that in the non-mathematical side of this table is essentially all the really important stuff. Okay, so these are the mathematical objects, and now what is mathematics? Well, you know, we study these objects using, like I said, that part of language which has no ambiguity. So we use logical deduction, examples, counterexamples. We represent some objects using other objects. We use algorithms for summing, multiplying, and so on. But all of these things can ultimately be reduced to logic. So it's fair to say that mathematics is logic, and I will get into that a little bit. But before, I'd like to distinguish here my attempt at defining mathematics from what actually is mathematical practice, which is something else entirely. So mathematical practice includes drinking coffee, feeling frustrated, scribbling indecipherable symbols, even indecipherable to yourself just a few days later, making trivial logic mistakes, feeling completely lost, having stupid ideas, sharing your stupid ideas with your colleagues who take all of 15 seconds to understand why your idea is really stupid and pointing it out to you with friendly, kind patience. And then, so the mathematicians are all laughing, as you can see. Drinking more coffee, and then occasionally you're a bit lucky and you find something. So let me say, why is mathematics ultimately logic? This is a highly non-trivial fact. It has been known for the vast majority of the history of mathematics. And you could say, I'm being a bit simplistic, but at some point this guy, Frege, came along, and after many, many attempts by other people, he kind of got a very good attempt at formalizing mathematics. He came up with a language of sorts where, as far as he could tell, all the mathematics that he knew could be written in. And of course, when he came up with it, there was these kind of awful diagrams. And now we've kind of simplified it a little bit. So an example of so this language that he came up with, we call it nowadays first-order logic. And an example of a sentence in first-order logic would be this one. It says that for every x, if ax is true, suppose that, so there's this implication which is kind of the outer one. So suppose that the following is true. For every x, if ax, then bx is false. Then that implies that there's not exist an x where ax and bx are both simultaneously true, right? And if you manage to parse that, you're going to go like, oh yeah, that makes sense. And actually, up above, we have kind of a proof of this statement using simple logical rules such as generalization and modus ponens, actually maybe even modus ponens, instantiation and so on. Okay? So what's in the bottom is some kind of statement using first-order logic, and above you have a proof, which uses some kind of logical rules. And it is broadly believed that every single work of mathematics ever done or yet to be done can ultimately be written as a mathematical proof that uses the language of first-order logic. And I'd like to point out how absolutely amazing that is. So there is no other human discipline for which some kind of such broad, all-encompassing statements can be done. Like imagine trying to do this for psychology, for example. Every single sentence in psychology is going to be written using these words. And you can combine these words using these particular rules. There's nothing like that for any other field of human knowledge. And that makes mathematics very special. And in light of this astounding fact, one can understand that the job of a mathematician is ultimately to find mathematical proofs. So the question comes, how hard is it then to find mathematical proofs? Now, let's say one person, very important person, to first ask this in some kind of methodical way was David Hilbert.
He asked, how hard is it to find a mathematical proof? Is there some kind of method that we can follow? Nowadays we call these things algorithms, but he called them effective method. So is there some kind of algorithm that we can follow? So I give you some kind of statement, and you run your method, and after that it will spit out an answer and saying, yes, there's a proof for this, or no, there's no proof for this. Alan Turing, the person who invented the computer, actually did so in order to show David Hilbert that there was no such method. We could call this Turing's theorem, although Church formally proved it before in a less convincing way, but logically equivalent. So Turing would show that there exists no algorithm that will succeed in finding all proofs that exist. And in doing so, he invented the computer, and everyone here has a computer in their pocket. And this was the guy who invented it. And he invented it in order to answer Hilbert's question. That's why he invented the computer. Now, Kurt Gödel came along. He's also a very important fellow for other reasons. And he asked a couple of decades later, so there's no algorithm to find a proof, but suppose that I'm okay with I just want to know if there's a proof up to a certain length, n. So these proofs have sizes, you can kind of bound the size of the proof, and you can ask, suppose I only want to know if there's a proof up to a certain length, n. So I want to find a proof of this length up to length n if one exists. And now, obviously, there is an algorithm that does this, namely, I go over every single proof of length n and see if it's actually a proof of my statement. This is what's called exhaustive search. It's an algorithm of exhaustive search. And of course, you can do this, but it takes a whole lot of time. And what Gödel asked is, can I do it efficiently, say in time n squared, or n to the c for some constancy, where n is the length of the proof I want to find. So this is Gödel's question. Can we find a proof of length at most n if one exists in time n to the c for some constancy? Gödel was asking, ultimately, if there exists an efficient algorithm for automating the job of a mathematician. Computational complexity, which is the field that I study, studies this question and other questions like it. It is a theory that allows us to understand how difficult or complex are various problems, and this is one example of a problem we could study. Now, enter Sudoku. We all, or maybe hopefully most of us, have seen this 3x3 kind of, or 9x9 Sudoku puzzle, right? But we could generalize this to any size, right? We could define 16x16 Sudoku, or 25x25 Sudoku. So generally, there's a Sudoku for every number n, and it's an n squared by n squared board, and you want to fill the board with numbers between 1 and n squared, so that in each row, there's no repeated numbers, in each column there's no repeated numbers, and in each block there's no repeated numbers, right? So that's n by n Sudoku. And now I'm ready to defend this claim that mathematics is nothing but Sudoku. So as it turns out, the theory of computational complexity can prove the following, I think, remarkable theorem. There exists an efficient algorithm for solving Gödel's problem, meaning there exists an efficient algorithm for finding proofs up to a certain length. Or in other words, there exists an efficient algorithm for automating the job of a mathematician if, and only if, there exists an efficient algorithm for solving n by n Sudoku puzzles. And proving this is not obvious. It took several years. So it's actually easy to show that if there exists an algorithm for doing proofs, then there exists an algorithm for solving Sudoku efficiently, because you can actually essentially write a Sudoku puzzle using first-order logic. That's not very hard to do. The other direction was actually quite hard, though. So first, this very important theorem by Cook and Levin showed that finding proofs can be, well, if you want to find any proof, you can actually find proofs of simpler statements. Like, these are very simple statements. And then this somehow translates into some graph where you have edges, and you want to partition the graph into triangles, and that was 81, and then 82, this kind of, you show that, these like triangle partition problem can be represented using a Latin square completion problem. I don't know if any of you have seen Latin squares, mathematicians probably have. And then in 2003, this Yato fellow showed how Latin square completion can be represented as a Sudoku puzzle. So there's this long line of, we call them reductions, showing how actually finding proofs, if there's an efficient algorithm for Sudoku, you can run over this set of reductions and eventually find one for solving proofs. And as a conclusion, mathematics is Sudoku. Okay, so in complexity theory, we have a way of understanding the relative difficulty of solving a computational problem. So relative to each other, Sudoku and mathematics have the same difficulty. And we have seen that the two problems of finding proofs and solving Sudoku puzzles have the same difficulty relative to each other. But what about in absolute terms? I mean, so mathematics is just as hard as Sudoku, and you could ask yourself, well, but how hard is it actually? Is there an efficient algorithm or not? Of course, if there is, so now we can rephrase Gödel's question and say, well, does there exist an efficient algorithm for finding proofs or equivalently for solving n by n Sudoku puzzles? I mean, we still haven't answered the question. We just said that the answer is the same for both, right? This is what is known today as the P versus NP problem, which is considered maybe one of the most important problems in mathematics. And, okay, that's what I have to say. Thank you.
Thank you. Thank you, Professor Bruno. And now we will look at deep and dark space with Professor António Silva from Institute of Astrophysics, who will talk about the Euclid mission. And let me put your presentation here. Aha, here it is. É melhor bocadinho mais ali, para não fazer interferência. Estou a ligar, já está.
Ok.
Pode experimentar. Isso mesmo.
Há qualquer coisa ali em cima.
Mas vai deixar de estar.
Ok. Ora, muito bom dia, boa tarde, não tenho ideia de que horas são. Em primeiro lugar, gostava de agradecer a possibilidade de falar-vos sobre a missão espacial Euclid. Eu estou na missão espacial Euclid desde há muito, muito tempo, desde o seu início, desde a sua proposta. Nos tempos à volta de 2007, essencialmente. O título é Unveilling Late Time Cosmic Acceleration, mas I'm speaking in should I speak in English? Yes, okay. So don't be fooled with the word late time cosmic acceleration. In fact, late time here means more or less 10 billion years of the foreseeable age of the universe. And the universe is about 13.7 billion years. So in fact, Euclid will look quite deep into the distribution of galaxies in the universe. So, but Euclid is not only a mission about the late time evolution of the universe. It's in fact much, much more than that. And I want to highlight two aspects in this talk. One aspect that I always tell to my students in the primordial universe course of the master's or the PhD is that in fact Euclid is able to indirectly test models, physical models of the primordial universe when the universe had an energy scale much, much larger than the scale that we can probe in particle physics accelerators nowadays. The other aspect I would like to highlight is that, in fact, together with this story of Euclid at the Institute of Astrophysics and Space Sciences, including the team at Faculty of Sciences, is that we, in order to participate in the mission, we needed to have national support. So Euclid is one of the first missions, and in fact is the first mission of ESA, where a Portuguese agency, at the time, we are talking about 2011, needed to sign a memorandum. It's not a memorandum, it's a multilateral agreement. So we needed to have our agency to sign a contract together with all the funding agencies of the Euclid Consortium to actually fund the in-kind activities that each different country would contribute to. So today I will tell you about an expertise that didn't exist in 2010. And since we are talking about, I think, the main topic is innovation, I want to highlight that progressively, sometimes with difficulties, sometimes with some successes as well, and we have many successes, we were able to develop a new expertise that now is, makes our group to be part of, is seen as a player in particular in the field that is survey planning. And I will tell you about this. So, okay, so what is the primary objective of Euclid? So Euclid, basically, the objective is very simple. It's just to measure the shape, position, and depth of as many galaxies as we can see when we are doing the survey of Euclid. With that, we will be able to measure the distribution of matter. And why we want to do that? Well, basically, there are 4 items there that highlight the main scientific objectives of Euclid. So, on one hand, by mapping the distribution of galaxies around us and in deep, mostly, of course, in the extragalactic sky, because when we have the galaxy, the region, the galaxy area in the sky is obviously covered, with that, we are able to measure very accurately the accelerated expansion of the universe. On the other hand, by doing so, we will be able to understand what actually accelerates, what is the dynamical behavior of what is causing the accelerated expansion of the universe. And then it will allow us to test very important and fundamental hypotheses about the physics models that we use to understand the origin and evolution of everything that we see in the universe at cosmological scales. And that is, Euclid will be able, by doing this cartography of galaxies, will be able to test gravity. And in fact, Euclid will be able to tell if general relativity is a good model at cosmological scales much before the LISA experiment will be able to test gravity models. On the other hand, by mapping the distribution of galaxies and using the relation between the distribution of galaxies and matter, we'll be able to constrain very well the dynamics of dark matter. Dark matter is one of the fundamental questions that we are facing today in physics, together with what is the component that is accelerating the universe. These are 2 fundamental questions that we do not have an interpretation at fundamental physics levels. But Euclid, by doing a rigorous mapping of the galaxy distribution around us, will be able to tell us a lot about these 2 components. And these 2 components, basically, today we believe that they make up about 96% of all energy density components of the universe. So one of the questions that Euclid will answer is, it's a very simple question, is what is the universe made of? We think that we know what the universe is made of, but for example, we know that ordinary matter that is made by quarks and leptons, this matter only amounts for about 4% of what there is today in the universe. The 2 other things, which is something that we call dark energy that is responsible to expand, make the universe to expand in an accelerated way, and the dark matter, these 2 components, we don't have good candidates to try to understand them physically. So Euclid will be a very important mission for this aspect. Euclid has 2 instruments. One is, let me see if I make it. So one is a visible instrument, will operate and collect light from the galaxies. That is the image over there. And then it has also an infrared instrument that will capture infrared light from the instruments. With this second instrument, we'll be able to measure the depth of the galaxies. Not all of the galaxies that Euclid will see, but many of them. And then we will use combinations of information obtained from Euclid and from ground observations to complement and to try to identify precisely the depth. We in cosmology mention redshift, of the galaxy. So Euclid will make the largest, very accurate measurement of the shapes of the galaxies, as well as positions in the sky and depth of the galaxies. This will be the most accurate survey covering almost 1/3 of the sky, the visible sky, for the first time. Now, what you see over here is a survey, a galaxy survey made by some very old galaxy survey instrument. No, the instrument is not old, the data release is old. And typically, Euclid can make this kind of images, but much more deep and with a lot more galaxies. Right, so in some sense, you can say that this is an old map of Earth, and at this stage, we are more or less, from ground observations, we are more or less like that, but Euclid will make a very perfect map of the nearby universe and deep universe. In some sense, we are Google mapping the universe, okay, with our survey of galaxies. Now, for example, so this is the survey of galaxies. Oh, right. So if you zoom in a portion of those kind of surveys that you do, you can see that galaxies are distributed and they have patterns that are not by chance. And these patterns that you can identify in the structure, they are strongly dependent on your physical models, not only about the late-time evolution, but about the primordial phase of the universe. Now, I like to do an analogy here between cosmic webs, so that pattern is called the cosmic web. I like to do an analogy between cosmic webs and spider webs. And as you can see, on the right-hand side, you can have very many shapes of spider webs, right? Because there are different spiders, and the colleagues from biology can tell me more why a given species does spiders in a given way. But I use this example because one day I found a fantastic paper from biology that was studying the impact of caffeine on spiders. And they noticed that the type of web that spiders do depends a lot of the amount of caffeine that you put on the poor spider, right? So these are two extreme cases. On the left, you have a spider with no drugs. On the other side, you have a spider that was heavily drugged with caffeine. So it's the same thing with the cosmic web. So cosmic web also depends on the different amounts of matter that you put in your physical model. So it is very important to understand what is the physical model, what are the particles that were present in the early phase of the universe, and how they interact, and how they allow the evolution of the universe to progress. So these are numerical experiments. These are n-body simulations. We are just seeing the dark matter component because these simulations also have hydrodynamics. But you can see that depending on the different amounts of dark matter, dark energy, and baryonic matter, you can have different patterns. And that's what Euclid will do. Euclid will measure the galaxies in these patterns and will, using statistical probes, will infer the dependence of those patterns with the cosmological and fundamental physics parameters, okay? So here is a more detailed view of that process. It's not only about seeing one, like the integrated distribution of galaxies. It's about seeing the distribution of galaxies at different depths. So this Z is redshift, so the highest value is the earlier, so back in the past, you have the distributions of these filamentary structures containing galaxies. So since Euclid is going to see several depths, we can discard, we can constrain many models of cosmological evolution and therefore infer about the key ingredients of the universe. So for example, all these possible theoretical scenarios, then the patterns, we are not comparing images, we are comparing statistical patterns inside these images with the statistical patterns that we observe, okay? So for example, this selection of numerical simulations. Just what you see here is the evolution with time for different models. And here what is changing is basically the parameters are over there, but basically it's the amount of dark matter, dark energy, the Hubble constant, and also the primordial power spectrum. And this is the spectrum of perturbations in the very early times, related with the generation of the perturbations by some physical mechanism. But for example, you can look, all this assumes, for example, that dark matter is something that only interacts gravitationally. Okay, so it does not interact by any other interaction type. But if you assume that actually dark matter can interact with itself, you can have different models of dark matter which build different patterns. And for example, when you are forming objects with a different number of satellites and so forth, satellite galaxies. So by looking at those satellite galaxies and doing statistics over many of these objects, you can tell very precisely what is the nature of dark matter. This helps a lot building models at the particle physics level for the best candidates to explain what we observe today. Okay, let's move forward. How Euclid is going to do this? Euclid has several, we call it probes. Probes means that there are observables that we can measure, and from these observables we are able to extract science. One of them is the so-called lensing probe, and in particular one of them is weak lensing probe. Basically consider that we have a galaxy with some shape, and then the light from that galaxy, as it travels towards us, if there's matter, significant amounts of matter between the galaxy and us, what we will see is distortions of the shape and the form, the shape of the galaxy throughout its path. Of course, looking only to one galaxy is not sufficient, and in fact, weak lensing observations, they are statistical. We need to do this for many, 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 many galaxies. And for example, here is a dummy exercise where you put all the galaxies with the same shapes in the back, and then you assume that between that artificial constructed set of galaxies, you put matter between the galaxies and us, or your observer, and then what you see are lensing patterns, so off and on, we are seeing off and on. So what happens here is that the shapes of these galaxies are distorted. Since Euclid will be able to map these at various depths, from observing the distortion of the shapes of the galaxies that are due to these lensing effects caused by the matter that is between the galaxies, we are able to reconstruct the dark matter distribution back in the past. There is also strong lensing events which are very visible. For example, these arcs are caused by strong lensing events. Euclid will also see them, and they can be used to test models of gravity, for example, because they can be a good probe for cosmology, or for gravity. Now, Euclid, I'm talking about Euclid, and Euclid has launched. So it was launched on the 1st of July, and it was launched by a SpaceX Falcon 9 rocket. And it was sent very far away, beyond the moon's orbit, to a point which is the second Lagrangian point, and is revolving, is orbiting that Lagrangian point is at the center, and then is doing orbits. So this is, since launch, this is what Euclid has been doing. Now we are in the phase of testing of scientific performance and readiness for science. We hope that in the beginning of the year, we'll start the so-called science operation phase, the survey for the weak lensing. Of course, I had to show something. This is, after 1 month, ESA decided that we should put some very raw, and in fact, they are early commissioning test images from both instruments. So this is the visible instrument image, and this is the NISP instrument image. But these are untreated, okay? So they are just as you get them from the telescope. And what is funny about this, what is very interesting about this is that, so I've been following Euclid since the first days, and I've seen, I'm very, 1 minute. I'm lucky to be seeing these images because if you zoom in there, you can see many, 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 many more galaxies. It's extremely exciting for us. Now, who are us? And what is the expertise that we are developing here at IA? At IA, there is some typos here, but I think I will talk about the people. So what have we proposed as a contribution to Euclid? What we proposed was, okay, so first we needed to see what the consortium was lacking. That work was done until 2010. By 2011, we were able to isolate a possible contribution that we were fine and secure that we could do. That contribution was basically what's in there. We are doing the Euclid survey planning. Our objective in this team, so I have to tell you that this team that you see over there is a team that guarantees our in-kind contribution to the contract that was signed by FCT and now is secured by PT Space. These people have just apparently it's a simple task, but it's a very hard task. These people have to plan the sequence of observations. The satellite is observing so it uses stop and stare, so it will look in one direction for about 1 hour, and then it needs to move to another place. Since the field of view is very small, it needs to cover the whole sky in many, many, many pointings. And it will cover about 15,000 square degrees. To do this, we need to observe during a lot of time. So the survey of Euclid will be, in principle, complete within 6 years, okay? But there are extensions, and the performance of the instruments are always never to the point, and probably we will have an extension of the mission. So we need to have a team for 6 plus, possibly 2 years. These are people that have worked since 2011, and they are the team that we have built here at IA School. So some of them are here, Ismael Tereno, I see David Oliveira. David, I'm sorry, there is a... You are back. So it's not formal. Okay, so these are people that have been working, and I highlight, of course, Ismael and João Diniz. You have already heard about them. I will not talk about this, moving forward. So what is our main contribution to Euclid? I'm wrapping up. So our main contribution to Euclid is basically to develop an algorithm of mapping the sky according to the requirements. There are scientific requirements, there are instrumental requirements, there are calibration requirements, and that job is extremely hard. The code that, I'm going to put that movie to work, what we will see there is the Euclid console, Consola Euclid, that basically you will see on the left time passing. This is according to one of our reference surveys so it was previous to launch, so it was to simulate how it would work in the future. What we will see here is time passing, and this is how we cover the visible sky with fulfilling all the requirements that we need to fulfill to put this forward. For example, this is a pipeline that this pipeline was non-existing at the faculty, and now it is there. And the most important is that it is a new expertise that we have, and we can contribute to other missions. So we are a player in this area of survey planning. Now, also, I wanted to see if you, since I don't have time, if you want, please come. So this is the Euclid console. The main code, so the total of the pipeline is about 70 kilo lines of code. The main code is called ECTile. The author is João Diniz, is from our physics department. João Diniz is the main developer of ECTile, the heart of the pipeline. And this console is possible, and we are the only ones inside the consortium of about 1,500 people that delivers this product to the mission. Now, this team, very rapidly, I'm almost really over. So what I want to say is just a few things. This team gained a lot of visibility. It received prizes, like, for example, the team prize that was awarded to the Portuguese team in 2020. João Diniz got also a prize as senior award from the Euclid Star Prizes in 2023. And more importantly, ESA was so interested in our planning tool that decided that for operations, they wanted to count on us, and it was the first time that a science mission used academia institutions to do the planning. So we are now actually about to start doing the planning during the operational phase. This tells you how, let's say, ESA trusts us on our work, okay? Now, very important. ESA also proposed that from the launch onwards, we should organize themselves in different way, and we need to create a system operations support team that basically does the planning of the mission when it is flying, okay? That operations team is led by Ismael, is also here. So, and is funded through ESA Prodex fundings that come naturally from PT Space and national funding. There's an extension already on the line of sight, and we hope so, in the sense that actually PT Space says, yes, we will continue to fund you beyond the first 3 years, but this has cycles, depends on ministerial meetings at ESA and the Prodex program, but during the whole time of the mission, which is typically 6 + 2 years, we will get this amount of funding for those years. This is already secured. Moreover, ESA recently is in contact with João Diniz, because João Diniz, in this initial phase where the satellite was launched very recently, we need to put all manpower there, and ESA asked Faculdade de Ciências to try to have João Diniz in full time during this period. So this is my last slide. Of course, it's not only the technical aspects that matter. What matters then in the end is the science. And the science, I just drop here just a few indicators. We have about 35 IA researchers, Institute of Astrophysics, working or that have worked already in Euclid since 2010. Half of them are from Faculty of Sciences, okay? This is very important. On the other end, in terms of official publications, it's very important to be involved and to participate actively in missions. Since 2019, basically, there were 42 publications, official publications of Euclid signed by Portuguese members. And basically, they are all here at the faculty. There are some that are not, but most of them are. And this allows also applications to scientific programs. Okay, this project was able, for example, this is an example, since 2020, we gathered from scientific competition in scientific projects about 400 kilo euros. And this is extremely important to exploit the science of Euclid. Of course, with this, there are grants. And also, I'm not even talking about candidates that come to Lisbon now because we are a player in this type of mission. So what I finish with is, we all want to go for lunch, right? Is to say that everyone is welcome to participate in Euclid, in its science, You do not need to be a cosmologist. You can be a particle physicist, an astrophysicist, or even someone interested in that. Of course, if that's the case, please come to Euclid, come to the Institute of Astrophysics and Space Science, meet our team and our scientific researchers. Thank you.
Thank you, Professor António. And we hope that this morning was inspiring for you, that it has sparked your curiosity. Welcome again. We hope you have nurtured your mind as well as your stomach during this lunch break. Before we start session 3 and we continue our scientific journey, bear in mind that we had global challenges during our morning's discussion, and they remain present in our mind. So I would like to start our afternoon session with another testimony by a researcher of ours. If this collaborates with me, yes.
Desde há bastantes anos que a minha investigação se tem centrado no estudo dos chamados extremos climáticos, em particular no estudo de secas intensas e prolongadas e de ondas de calor intensas, as quais estão ligadas à ocorrência de grandes incêndios rurais, um problema que me tem vindo a ocupar muitíssimo. Em particular, preocupa-me o estudo da previsão do chamado perigo meteorológico e também do impacto que as alterações climáticas irão ter no regime de incêndios. Trata-se de uma investigação direcionada para os utilizadores, muito em particular a proteção civil e empresas ligadas quer à indústria do papel, quer à distribuição de eletricidade. E gostaria de salientar a plataforma Ceasefire, de que sou responsável, e que dissemina operacionalmente, quer por telemóvel, quer por internet, um conjunto de produtos ligados à prevenção e ao combate de incêndios rurais para Portugal, mas também para o Brasil e para Moçambique.
Thank you, Professor Carlos. Let's not forget our slogan for today: we must act today for a better tomorrow. And for sure, innovation has a very important role in this journey. So now it's the time to discuss the path from science to innovation. And for that, I welcome to the stage Rita Tomé from Tech Labs to review the last 5 years of the innovation strategy and results at Ciências. She will then proceed with the presentation and moderation of the roundtable, the different paths to innovation at Ciências. Let me put your presentation here. All yours.
E aqui, fui passando, ou aqui.
Pode ser, nos dois.
Alright, obrigada. Ainda não está projetado.
Não está, mas vai estar. Deixa-me ver, desculpa.
So, good morning, everyone. Like Marta just introduced me, I'm Rita Tomé. I'm the coordinator of Tech Labs, the incubator and area of innovation and entrepreneurship of this institution. And I'm here with you guys this afternoon to share a little bit of the results of the work we have been conducting in the past 5 years. So let's start with, first of all, the vision we have, and it's more and more one of aggregate results. So to have a 360-degree approach to innovation, one that allows the institution to become more and more innovative, and one where innovation is tackled and dealt and worked outside the walls of the incubator that we have around for 30 years. But we don't want innovation to be exclusively centered in this building within the campus. With that being said, so we assume three main missions to pursue this vision that I just shared with you. By one hand, we are the unit responsible for managing all the incubation activities happening in the incubator we have within this campus. We are the area of innovation and entrepreneurship, hence the number of activities and programs we have targeted at stimulating activities, targeted at bringing innovation and entrepreneurship topics among our different audiences, researchers, students, professors, among others. And we are also taking a look at how we can redefine and restructure our industry network and this important connection we need to stimulate between academia and the business world. Let's deep dive in very briefly in each of these missions that I've just presented to you. So in terms of incubation, what we have in this building that it's quite close to MARE, sitting within this campus for 30 years now, is a lively ecosystem. First and foremost of a multidisciplinary portfolio of startups and spin-offs, all of them based on science or deep tech solutions, with also an infrastructure which is kind of unique, at least on an European level, which are our support labs that are open 24/7 to all the companies we incubate, and that bring a lot of value, added value to projects, especially in a very early stage of development. We have more than 3 million in equipment there that can be accessed very easily by all these startups we have with us. Also, we have a dedicated program through which we support all these companies with regular meetings and a checkup of needs and pain points for them where we can help and support them. And of course, we do that not only with the team we have in the incubator, but also with the network of mentors we have, with the partnerships we have in place with service providers that are key to these companies, such as accountancy, legal support, among others, and also with the relevant organizations from the national ecosystem to which we are very close to. Last but not least, what we also do is make this bridge between the investment area and on a national and international level. We are very close to most of the business angels and venture capitals investing in the areas where we focus in as an incubator, which is also key for the development of these companies. Some of our numbers, so we exist for 30 years. Throughout these 30 years, we have supported more than 120 companies. And at the moment, we have a portfolio of 30 of them sitting with us in the incubator. These companies generate around 100 annual qualified jobs. This is data from the last biannual questionnaire we had around the incubator to get some data from our companies. And overall, they have generated more than 40 million in revenue. We are also being capable of attracting a pool of very interesting international startups. We have already 15 around from many different countries, as you can see in the slide, from Brazil to the United States, France, Spain, among others. And this also shows the quality of the work we are doing if we are being able to attract these companies to, when they decide to come to Portugal, they choose us as an incubator. As an area of innovation and entrepreneurship, some of also our numbers from the past 5 years, we have had more than 31 invention disclosures, 18 patent applications, and 6 spin-offs being created in a wide range of areas, from chemistry to biomedical engineering, informatics, and so on. So very humble, but still great numbers for the resources we have allocated to developing this area within the institution. What we also do in terms of stimulating innovation and entrepreneurship around is promote this methodology we developed called Science into Business. It has 3 main pillars, and a lot of activities happen there since its creation. Let's focus on what we are doing now at the moment. On the learning pillar of the methodology, we have a range of optional courses from bachelor degree to PhD so that our students can have some sort of contact with these topics. And also non-formal training programs and seminars, workshops, and so on that we do here at Ciências ULisboa, but also in partnership with other schools. I'll go into that in just a few slides. On the selection one, we have had for a couple of years a call for projects. That was our best try to understand what applied research work is being conducted in the institution and that we can help valorize and reach the market. That has changed over time, and at the moment what we do is a program called Impact Program. It's a training program that tries to capacitate our researchers to these topics of entrepreneurship and innovation. We have had 20 participants in the last edition of this year. And now this training program is going to go hand in hand with the call for investment, for funding that that Ciências ULisboa has also in place, and that will finance up to 50K an internal project. On the evolution phase, pretty much what we do is we treat every student who has an idea, every researcher that files an invention disclosure or that participates or gets involved in any of our science into business activities as if they were a startup from the incubator. So they have access to the whole ecosystem we have in place there, because we know that it's not after a semester or it's not after doing a 3-week training program that they will be ready to pursue their project. So we give them all the support that they need through time so that they don't quit their projects and keep on pursuing them. In terms of the work we are trying to develop to redesign the industry network of Ciências ULisboa, our vision is once again aligned with the 360-degree approach that I just told you about in the beginning of my presentation. We want to build on the more than 150 industry connections that the faculty has in place yet, and kind of see how can we deepen these connections in a more aggregate approach, seeing that there's benefit from this in different industries and companies to create synergies, either with our students, researchers, with the startups we have around, and also with the training activities going on in the institution. These two are already being tackled. Startups through the activity of the incubator, of course, and students, we know that there's a lot going on already, like for example, Job Shop, which is a great effort to try to make this bridge and connection between our students and companies. What we then realized it was important as an open door to enter in a lot of companies was training, and because of that, since last year we have created Ciências, which in pretty much 1 year of activity has implemented more than 14 training courses with more than 250 participants and 22 external partners getting involved in these training activities, which is already a great step to try and make these connections with a number of external partners from the faculty. In terms of our research work, what we are beginning now, the very first steps of the process, is trying to map out all the scientific infrastructure of the faculty and try to give a form and internal processes so that this somehow gets visible to external partners in order to promote more synergies to arise. And of course, try to promote that the connections that some of our researchers already have with a lot of companies have a more aggregate and interdisciplinary approach. This is what we do. Also, what we do is especially since 2019, we have started our efforts to grow globally and expand the work we do. Not only are we being able to attract international startups like I just mentioned, but we are also conducting job shadowing missions that allow us to understand better more mature ecosystems than ours, which can help us improve the work we do. We are also in international networks that we joined with this main goal of improving our practices, meeting peers from all around the globe, and once again, improve the work we do. And we are also very actively on an open door perspective to what has been more than 50 delegations that we have received from all around the world to showcase the work we are doing here at the Faculty of Sciences. Last but not least, we are also worried in communicating and with the outreach of all of these activities we pursue. We do so by a number of different strategic paths we pursue. One of them is actively collaborate not only with different schools from Lisboa, but with the rectory itself in a lot of isolated initiatives or huge projects that can really mean a shift in the way the university as a whole is tackling these topics. But also, for example, with the municipality of Lisbon, because we are active partners of Project SEED. It's a project that the municipality is promoting to try to bring entrepreneurship education to high schools from Lisbon. We also have a monthly newsletter, try to be as active as possible in our social media accounts, produced 2 publications targeted at these topics, created a podcast that is going to finish its first season in December with 20 interviews with relevant stakeholders from our ecosystem, released and launched our news website, which has an area there dedicated to resources, a lot of audiovisual content that tries to bring literacy on these areas, and have organized more than 50 events from open days to investor days, among others. And last but not least, I could not finish this presentation without a huge thumbs up to our team. The Innovation and Entrepreneurship Commission that was created by the present board of directors last year to continue help to pursue the strategic vision for this area of innovation and entrepreneurship, composed by Professor Jorge Maia Alves, Professor Fernando Antunes, and Professor Teresa Vieira. And also the incredible team operating this miracle, which is to put everything that I've just mentioned in my presentation in place. And that is on a daily basis, implementing all of this. So this is it for me. I think I was able to, in a couple of minutes, to show you what we have been trying to establish and grow as an area of innovation and entrepreneurship of this institution. And I think we end up in a very positive note because we have reached so many incredible milestones in such a short period of time. But still we know that there's work to be done. And so I think our next moment of this track dedicated to innovation is going to help us reflect a little bit on the challenges that we have ahead to keep on pursuing this. So I'm going to finish my presentation by thanking you all for your attention and asking that João Silva, Francisco, Sara Reis, and Rui Cortes join me here at the stage for the round table. And I ask for a round of applause for them, please, while they join me.
Temos ali aqueles microfones.
Let's see if this, yeah, it's working. Perfect. So first of all, thank you very much for accepting our invitation to be here today. We try to balance this roundtable with people who have very biased perspectives on these topics, and also external stakeholders that can show and bring us a more external perspective on this. And as a starter, let's just do an overview of this, that what we are trying to do in this roundtable is show you the different paths of working innovation at Ciências ULisboa that we are trying to pursue. Okay, and so as a kickstart to this conversation, I'm going to ask you to just do a very brief presentation of yourselves, 2 minutes each, so that we keep the time, okay? Maybe starting here, Rui, you can go ahead.
Good afternoon. Thank you, Rita, for the invitation. My name is Rui Cortes. I'm the founder of Linal Portugal. It's a 10 years company, work mainly in healthcare improvement consultation. And in 3 or 4 years ago, we joined Tech Labs, and we move our business to digital health and benefit a lot from the partnership with Tech Labs. And it's the reason we are here. Thank you.
Is that one working?
So, hello, good afternoon, everybody. My name is Sara Reis. Let me also mention that I was a student. I've worked here, closely 10 years ago, and currently I'm working in a company that is called Frontier IP. And Frontier IP is a company based in UK, and me and my team, we are here in Portugal. We also created the subsidiary of Frontier IP in Portugal, and our goal is to transform or identify technology that is relevant to transform into products and successful innovation that enters in the market. So I'm here just to share my perspective on the technology transfer and commercialization of technologies.
Thank you very much, Sara. Francisco.
Okay, thank you, Rita, for the invitation. My name is Francisco. I am a professor here at the faculty in the Computer Science Department, also a member of LASIGE, a researcher. And my perspective here is to talk a little bit about my collaboration, especially with, for instance, with Unicage, that is a company that is established in tech labs, and also my previous experience with collaborations almost with all the three big technological companies in terms of the relationship between research and industry.
Perfect. Thank you very much. João, last but not least.
Thank you. Good afternoon to everyone. I'm here as a finishing PhD student. I've been in this house since 2009. And now we're going to start a project called Keep It, which is also one of the companies in Tech Labs. So I'm here to give the perspective as still a student, a finishing PhD, and a starting co-founder of this new company.
Perfect. And I will start precisely by you because the mic is there, so perfect timing. And I wanted to ask you, actually, you co-founded one of our most recent spin-offs that was just created in August, so very fresh out of the oven. What was the motivation behind that, to pick up on the work you are developing on your PhD, and after that just jump right into the crazy pool of creating a company?
Yes, so the motivation is to finally materialize sort of a dream that has been in the doing for a long time. So we've been working on this technology for a long time, since my master's. And since then, for us, the natural way to go would be to go out there with it. So the motivation for the creation of the company is its own. So it's the concretization and the final validation for all of these years of work.
And I know that the path is still very fresh, very few steps, but so far, challenges, advantages of pursuing this, what can you share with us to deepen a little bit more of the experience of finishing a degree and just starting a company?
So every step is a challenge by itself, but as a step it is, the step we give is the challenge we accomplished as well. So the benefit is not only we are working, it's an opportunity to work on a project that I'm so familiar with, but it's also a validation of the work. So many times we are doing investigation, and in the back of our minds we are asking, what is this for? And what is it for is exactly what I'm doing now. I'm making it real, the what is it for of all this investigation. So it's the metamorphosis, so the transformation of the investigation into the product, into the idea, into the real world, so coming out of the paper.
So in the end, the impact now that this is having on a real and pressing problem, because maybe for context, if you explain just what Keep It is trying to do.
So yeah, we are working on energy storage, which is for the grid. It's one of the ways to finish the transition and the decarbonization of the energy distribution, electricity. And we will be one of the small pieces or a big piece on all this transformation that is needed, that it's so much urgent.
Great, thank you so much for the contribution. Francisco, I'm going to you now. Talk us a little bit about this collaboration with Unicage, and maybe you have others, not exclusively this one. But I think it would be very interesting to understand what added value, advantages and disadvantages does this bridge, making this bridge between research work and the educational one, because I know it's not exclusively just focused on research, but also on the talent that the institution is generating, has to you as a researcher, to LASIGE, to the institution at the end of the day.
Okay, so the collaboration with the Unicage is successful mainly because it's made by people that work in school, in close collaboration. We have goals that are shared, and we can, for instance, we had a challenge. We had some technology from LASIGE, some technology from Unicage, and we were able to join both technology and achieve a good place at the challenge. But globally, there is always this challenge to bridge between university and industry. As I was talking a little later on, is that in terms of time, our goals as a researcher is always more to create new knowledge, disruptive knowledge, but doesn't matter about the economical value at the short term. And when I talk to companies, it's always, they think at the short, medium term. So what I gain from this at short and medium term. So the idea is there is no solution, but there is always a trade-off. So the trade-off that I always try to have with these companies, okay, so we can do some incremental research that can value some of your products, some of your service at short, medium term. And at the same time, you can invest in our research as long term, and if you have the return of investments, it's okay. Not, because we need, normally as researchers, we need this investment, long-term investment, to have PhD students and so on, so we can create disruptive ideas. But there is always this trade-off between the time period where you get the return of investment.
And the ways of working and timing of things, so a lot of differences there that you need to find at the end of the day, a compromise. But you were also talking a little bit about talent and how is this important for students. Can you go a little bit more on that?
I was talking, for me, for my whole experience in these collaborations with companies, what I value more is not the product, not the ideas that are generated, but the people that we generate with these collaborationships. Normally we have these students that are working, PhD students, that see their work being applied to the real world, to see that they can, after a PhD, like the previous example from my colleague, to establish a new company. And it is very important for a student that is doing his PhD. And I think, and I believe that we should invest in critical thinking. So the idea is that to have these disruptive ideas, we have to really invest in education that promotes critical thinking, people that are not afraid to have new ideas, to risk, because incremental research is much easier than trying to do something that is totally different. But sometimes this is the most important part for establishing a new company, because otherwise, if you are forming students and researchers that follow the protocol, they will be replaced very soon.
Okay, great insights there. Thank you very much. Sara, going to you. You already explained what Frontier IP does, and you have a branch here in Portugal, so you have grown a lot to create collaborations with higher education institutions and research centers all over the country. how do you see that things are at the moment in terms of technology transfer, innovation and entrepreneurship activities in the country as a whole?
Okay, let me start also to share one of the opinions of the CEO of Frontier, that he is English, and when he started considering entering in Portugal, he thought that this is a question of time, that Portugal was not, this is like cycles, and the UK is already in a upper cycle, but the US is even more upfront. So it's a matter of time that we also, Portugal can also enter in the curve. And I started working in this area for more than 10 years ago, and I noticed a lot of difference. When I was, when I left my studies, when I started working, it was not common to say that we were working for a startup or we wanted to commercialize our research. And I remember also some of my friends mentioned that it was a shoot in my feet if I was going to open a company. So this was the mindset. And I believe that now is totally different. We are more willing to take risks, and there are opportunities and funding mechanisms to start a business. And if you notice, we have the name of the event is Ciências Research and Innovation, but in the past was just research. I think that innovation is important to be included, because innovation is when an invention enters in the market or is the society is using it. So it is related with impact. And currently, I think that we have gained some tools. We are also more mature on the commercialization and engaging with companies as well.
And how do you see ourselves as an external stakeholder positioned in this area? With a very key focus on what we do, what can we improve?
How Ciências can be more open to collaborations with the industry. So first, I think that we need to create stronger bonds with the companies, because most of the companies that I speak, when I mentioned that it is a technology of a university, the mindset is totally different if it is a technology of a spin-off. So industry, unfortunately, they have in the past bad experience with the universities because of the times, because of the objectives of a collaboration. So we need to change the mindset of the companies first, and demonstrate that we are a university that is open to collaborate, that understands their timings, their goals, and we can also adapt to their mindset. I think that starts improving a relationship, and then others come.
Okay, perfect. Thank you so much. Rui, going back to you, and I promise I didn't pay Rui to come here and just say good things about Tech Labs. I promise I didn't do that. But I wanted to start by asking you your experience of joining a university-based incubator, which has its particularities, and you can talk freely about them. But how did this bring added value to the pursuit of your business ideas? And the added value of being in an incubator which has this close connection to so many things, because then we can deep dive a little bit on how you were one of the companies that benefited a lot from these synergies that we were able to make. But maybe let's start there.
Okay, first just a fast sentence about my background is marketing. Now I'm a student, PhD student of public health, but I don't belong to the science areas, which means that when I joined Tech Labs, it was interesting but challenging. Interesting because it was an ecosystem that really helped us to understand what are other areas of knowledge that can benefit the company and develop new products, and I will speak later about this. But at the same time, were challenging because it was, even the business model is completely different. Because in the past, I just calculate hours of worker to make the commercial proposal, and in the business, in the scientific and digital health is completely different. And it was a long learning journey. And when we, parents, we have 10 years and 90% of people that work with us in the past or now come directly from universities. It is my way of, as a citizen, I really believe the talent that the professor was speaking about, the talent that universities bring to the society, and I really have the vision that we want to be one of the places that the students can choose to develop their thesis and stay with us or fly away. And when we begin to look for other areas to develop and diversity the company, each time I have an idea, I call Rita, we need to speak with some professor in this area. And it was really interesting because all the way that we speak with different professors in different areas, the reception was really interesting, and we create sometimes the idea moving on and sometimes stops because it doesn't make sense, or my idea was not aligned with the market and with the knowledge. But it was really interesting. And the last experience was 2 years ago in 2021. We work in the hospitals every day. We don't have office. We are just 4 people teams, and we work in the hospitals with professionals, and we know a bit the operation and management in healthcare, and we identify issues in healthcare organizations. And from that issues that the hospitals don't know how to face it, we bring ideas, we contact Rita in Tech Labs, and we try to develop solutions. And one of the last experience was with one student from here, Alice is over there, and Alice developed her thesis with a hospital in Lisbon. The thesis was develop a great product. Now we are already in 3 hospitals in Portugal and 1 in Ireland, and it all becomes with the thesis. And this is really interesting because if it was not the match between our idea, the issues from the hospital, and the knowledge in the university, probably the product will be stopped. Our role with the students, I am not a technician. I don't know anything about machine learning or data analysis, but is to support the students in the hospital. Don't let the student get lost in the hospital, and help them to be sure that in the end, they will achieve their result. First, the result with a good thesis. Second, try to develop products to the market.
Thank you, Rui. You already started talking a little bit about this, but you are one of the success cases of connections that we were able to establish between our incubated companies and our research units, namely in IBEB, in biomedical engineering. And I know that the story of Alice and how you achieved all of this was just the starting point of something bigger, right? So how is this collaboration evolving over time? Because this is also important, because sometimes we start by thinking how much work this will bring, oh, this will be huge, but sometimes you just need a small step to start something, kickstart something, to ignite something, and then things evolve organically and naturally, which I think was the case. Yeah. Can you elaborate a little bit on that?
Yeah, the first contact was with Professor Matella, and he invited us to present a company in the class. And immediately after that, some students tried to contact us to develop their thesis with some of our subjects. One of it was Alice, and now every year, and not just with this university, there are several professors that in the moment of the students choose the thesis subject, they ask us for subjects that the hospitals, mainly at the operation management level, because everyone in healthcare is looking for innovation in clinical area, but there are a gap to fill in operation management area that someone is not looking with the attention, the right attention. Thank you. And we every year we give some subjects. The students choose. We speak with the students and the professor, and then they developed. Now we are with other students from biomedical engineer, develop a decision tool supported, clinical decision tool supported in system, geographic information system, to help the future local health units to manage how they should use the resources. And this is a really win-win situation. And in this moment, we are trying to, we are not trying, we are implementing. It's not trying. We are implementing with an hospital, with 4 universities from different areas of background, innovation hub. Every year the hospital will give some subjects. The universities try to attract the students, and we will support them on a daily basis. And the goal is to finish the thesis and then try to find new products, assuring that the students will be their rights, like at least their rights saved if the products go to the market. And this is the strategy.
Perfect. It's such a great example of how things naturally evolve to such a wider project that can bring a lot of added value to all those stakeholders involved in there. Thank you so much for sharing. Thank you all for the contributions. In the few minutes we have left, because Marta really needs me to stick to the time, I would like to finish with a vision towards future. So looking at the future we have ahead, I would maybe ask João, and then we go again in this direction. What are your thoughts or ideas of how we can improve and build more strategies to implement innovation and entrepreneurship in Ciências ULisboa, looking at the future?
Maybe thinking about how I came here, which is mostly through the confidence of the professor. So I think it always starts somewhere in there. So a professor identifying someone that will have either already some talent or a lot of will to go further and start this journey together. So I think we start by the beginning. So it's where the students are, where the professors are, and we always look for in which way we can promote these connections and a good environment for them to develop their ideas and work together. And then as soon as we have that, the rest will come naturally. They will look for the programs that exist, they will look for the financing, they will look in ways to make their ideas come true. So I think we always need to start with the beginning, with the eggs.
Yeah. It's a very good insight to look at researchers and professors as the first igniters of this movement to happen within the institution, which I think summarizes a little bit of your ideas. Thank you so much. Francisco.
Okay, thank you. I believe the important role that Tech Labs has to bridge these 2 different worlds from university and companies that are different, they should remain different. I don't share the vision that industry should merge with universities. Universities should strive for knowledge, to train people with critical thinking, being independent, trying to find knowledge. If it has economic value or not, doesn't matter. The industry tries to find economic value, and these 2 worlds with different missions in the society should have these bridges. And the bridge, I believe Tech Labs is doing a great job, and I believe it should be important to have the students more in contact with these initiatives for bridging, because it's 2 different worlds. We can have these trade-offs, and it's great for everyone if we get them working.
Thank you so much, and I promise I didn't pay also Francisco for saying this. Sara, you already shared a little bit of some ideas, but maybe some more. I know you have. You are always full of ideas, so bring them.
So I was listening, and I was also thinking that some of my learnings. I don't know if you are aware of the concept market technology push and the technology pull. So normally what happens, universities try to pull what they have, the research that they have. And what happens is that industry normally is not ready, or the technology is not ready to be adopted by the industry. And what it works best in, this is from my experience, is when we go with and talk with the industry, with the companies, and ask for problems. Tell me, what are your problems? What are you struggling? And then the efficiency of the technology transfer increases a lot. And second, I also want to mention that you researchers, PhDs, you are also the face. You represent the university. And it is also your job to be in touch with the companies, to identify partners with whom you want to work, and create that trust for them to be interested in working with you. It also depends on you. Don't rely on just the professors or the institution to do that work. You can also have that role.
Thank you very much. Rui.
I think one of the interesting points that I can find is show to the professors what companies in tech labs has to offer, like Sarah was saying, to be more clear. And because we contact each professor with really receptivity, but from our proactivity. And probably if the knowledge from the professors what tech labs companies can be able to develop, and at the same time for us be more clear what is the strongest area in the university, probably we can create. And at the same time, with all the examples that are being developed in the different companies and the different research areas, create a kind of ambassadors to show to other students it's possible to make it happen. And with at the same time with the transparency that not all the research and the developing of products go to the market with success. And I think we should be honest with the students, because sometimes I don't saying in tech labs, but sometimes I feel that creates a kind of a promise that you will make this research and the product will be a success, and people spend a lot of years and the personal investment, and we need to be honest that some products will not have success, and I think it's critical.
Thank you so much. Anything else you might want to add? If not, can I improvise here? Because we have time for one question, maybe from the audience. I think we would run out of time and couldn't make any questions, but maybe let's improvise here a little bit. Is there anyone who wants to ask something? Oh, there's someone there.
And here he is. I was wondering, what would you have to say to someone who's at a university, has an idea, wants to transform it in a business, in particular regarding where the business and the university fall apart, and if they need to fall apart, or how do you foster the collaboration between two things which are now different entities? If someone could talk about that.
Let me try to understand if I get it, the question. So you are trying to understand how we can keep continuing working. A competition between... I see the point now. I think I'm not against the service provided by the universities. I think that can be also a first step before incorporating a company or a spin-off from the university. Why not? Because sometimes we should use the resources that the universities have, and I think that most of the directions of the universities are willing to cooperate and provide service to external parties. So I don't think it's a competition. I think that if it gains track record and it becomes a business, then we should think as a business.
Yeah, we talk about that as a positive, promiscuous relationship, that maybe in the beginning of something, it's very important that you have in place. And a lot of our regulation and internal processes try to bring transparency to this process, because we know that sometimes that's how things start. And we're okay with it. Okay, let me see. No, Marta is looking at me. No, yeah, you can add, you want to add something. Go ahead.
I can say something.
But very quickly, because
Yes,
Marta is going to kill us.
No, about the service. What I think is, as a warning, we should be always, as researchers, if we use taxpayers' money, we should strive for reproducibility. So we should strive for open access, for open source, try to be as transparent as possible. The economical value is something that, okay, if it happens, it happens, but I believe our main goal should be to create new knowledge that is good for society. If we try to be have the same goals as companies, then probably you will have some problems in this situation.
Thank you very much for your question and for your participation. We have to finish here. I wanted to thank all of you for your honest attention to the discussion that just happened here. But most of all, thank you for your contributions and for these active ideas and proposals of how we can improve our work. Thank you very much. A round of applause, everyone, and have a great rest of the event.
Thank you very much, Rita. Perfect timing. And thank you all to the invited speakers of the roundtable. This was a very enlightening discussion. And we will now enter our fourth session of the day. But before we enter the session, remember the testimonies that we have been sharing during the day. We have another one that we would like to share with you.
Venho falar-vos do trabalho que fazemos em Ciências e no MARE em termos de monitorização do Parque Eólico Windfloat, em Viana do Castelo. Trata-se de um projeto inovador à escala nacional e em muitos aspectos também à escala internacional, e que tem a grande vantagem de permitir reduzir a emissão de gases com efeito de estufa por produzir energia renovável. O trabalho que nós fazemos é fazer a monitorização ecológica desse Parque Windfloat. E com isso conseguimos garantir que, para além de ter impactos positivos a nível do clima, tem também impactos positivos, ou que conseguimos pelo menos reduzir os impactos negativos que podem existir a nível da biodiversidade, que é esse o trabalho que nós fazemos, conseguir minimizar os impactos negativos e potenciar os impactos positivos do projeto Windfloat.
Thank you, Professor José Costa. The global challenges continue in our mind, and they will continue not only today, but in the work that we all do here at the faculty. And now we enter the fourth session, Science for Society. And I start by calling to the stage Professor Cláudio Gomes from BioEasy to talk with us about impactful research and innovation in biomedicine and biotechnology. Let me switch to your presentation. Yeah, here it is. Here it is.
Thank you. Good afternoon, everybody. And thank you for the invitation to come here and present what has been a challenging project we've been involved since 1 year from now. And I think it's a good example on how scientific activity and work from researchers can impact positively in society, because as you will see, our project has both biomedical and biotechnological impacts. So I'm going to tell you about twinning projects. So I think we should start by framing a little bit what are twinning projects. So twinning are part of some of the instruments that European Union has created in the framework of the widening activities that aim to bolster the activity and the research of certain countries that lag behind in terms of indicators in respect to the high performance countries within the EU. So among these we have twinning, and basically the goal is to set up a consortium that will enable networking, that will increase the visibility of the institution within the widening country, that will promote training, exchanges of staff, training of students, that will capacitate the institutions from the widening countries in a way that this will leverage their research activity. So we set up to one of these projects, and it's called Twin2PIPSA, which means Twinning for Excellence in Biophysics of Protein Interactions and Self-Assembly. So I will use a couple of minutes to explain or to frame the importance of studying protein interactions and self-assembly. So to this audience, you all know proteins, and proteins are vital macromolecules within cells, and they do a lot of important functions. And these functions relate to their three-dimensional structure. However, there are conditions in which, sometimes the structure of the protein is altered, so you have misfolding, and this is associated to a number of human diseases, including cataracts, metabolic diseases, and mostly neurodegenerative disorders such as Alzheimer's or Parkinson's. So we need to understand how this self-assembly process can be regulated, both in healthy and in pathological conditions, because in what comes to disease, we want to find strategies that will block this process. But paradoxically, in some occasions, the formation of these assemblies is also useful in cells, and we create functional entities. And as you will see, we can also develop systems in which we have a biotechnological application of this process. So in overall, to achieve this goal, what we need to bring together is a complete set of multidisciplinary approaches that in our case bridge experimentalists, computational people, that allow us to look into this process in a wide perspective, from molecules to cells to organisms and back. So this is the context. And to set this up, we established a consortium, and the consortium is led by us here at the University of Lisbon at the Faculty of Sciences, and it includes partners from the universities of Copenhagen, from the University of Cambridge, and from the universities of Tel Aviv. And the reasons for choosing these partners will become obvious later on, because they were picked up because they represent expertise that we wanted to bring on to our institution to leverage our ongoing work. So here at the Faculty of Sciences, we realized that a group of 11 PIs that have diverse backgrounds, that were engaged into multidisciplinary research, and they were already collaborating. And it's noteworthy that this group of people comes from 3 different departments. Most of them are affiliated to BioEasy, but we also have a partner from MARE. But they bring together different approaches to study proteins and to study protein folding and aggregation using different methods. And then we were doing pretty well, but there were a certain number of things that we would like to do that we felt that we still need to be able to improve or to change or to be able to do new things at the frontier that would allow us to set up a cluster of excellence on studying protein misfolding disorders from a biophysical approach. And our goal is to use this knowledge to leverage important discoveries with an impact in biomedical and biotechnological processes. So the way to do this is by enhancing scientific collaborations, by increasing our local resources, staff competences, to strengthen also our management and administrative skills, because this is also an important component of this project, as you will see later on, and to develop joint research towards these goals. And for this, we identified the University of Cambridge, the University of Tel Aviv, and the University of Copenhagen, especially a subset of scientists within these institutes, as having very strong skills that would leverage our goal and our activity. So for instance, the University of Cambridge, they are world leaders into understanding the mechanistic basis of protein misfolding in protein aggregation diseases. In Tel Aviv University, they are experts in using biologics as biomaterials and also in translating scientific knowledge into applications. Our main contact point there has 90 patents, and they are very prone to transfer what they find at university level and in research to applications. And our partner in the University of Copenhagen is an expert in bridging together data from experiments with computational models and improve both by doing these things. So these were precisely goals that we were interested in pursuing. And through this twinning project, we are able to do this by fostering exchanges, by organizing training schools, by organizing joint events, by organizing seminars, by putting together people with different backgrounds, but also as a way of improving and having a long-lasting impact at the level of the institution. And for that, I think it's noteworthy that to note that we set up a work package which is aimed to strengthen the research management skills at Ciências ULisboa. And basically this involves sharing experiences with the other partners to learn from best practices, to improve certain management procedures, to improve the way applications are approached, to assist researchers in providing action plans for funding strategies, to support researchers into making applications to international EU level grants, and this is going very well, and I think it's an important that has an impact not only on biological sciences, but it's meant to have an impact across fields. So I think this is an important impact of this project within our daily lives. And very soon in December, they will be organizing at Ciências ULisboa in the framework of Twin to PIPSA. They will be organizing an event open to the community to precisely explore and learn how you can foster applications within the framework of EU. So I think this is an important outcome, because the other outcomes, how we achieve scientific excellence by doing staff exchanges. So our students and the staff goes to these partners, and we focused on a particular topic, a particular methodology, and vice versa. It's very important to have these experts coming and having daily contact with our students. We have the training schools. We'll have 3 training schools during these 3 years, which were designed by us in a way that they will fill gaps in knowledge that we have identified in our, let's say, scientific operation. We develop joint research. We capacitate the institution through this, fostering of the procedures within the grant office, and of course, dissemination, communication, exploitation are very important. For practical reasons, we have not yet organized a company-centered event here in Tech Labs, but it's going to be organized soon next year. The idea is to showcase this type of research to the non-academic community at large, in a way to foster synergies that may encompass services, either valorization of knowledge or something as valuable to us as to a company, like our participation in scientific advisory boards, and basically know where the experts are. So this is a project of 1.2 million euros, and it started last October. And these two edges, which have a goal of on biomedical and biotechnological processes, relate to these two angles that are being studied. So on the one hand, we're studying how protein misfolding, aggregation, and self-assembly occurs in neurodegenerative diseases like Alzheimer's. So we're studying the proteins that are implicated in these pathologies, and we are studying how this process can be prevented by using antibodies, by using molecules that occur naturally within the cell that prevent this. And this will generate knowledge that hopefully will pave the way to understand better disease mechanisms and mitigating therapies. And at the same time, one of the other flagship projects within the Twin2 PIPSA is the study of bioadhesive proteins from marine organisms. And this, of course, we're exploring this to try to develop ways in which we can have better cell-to-cell adhesion that ultimately can lead to bioadhesives that can replace medical sutures. So these are long-term goals, and that we are implementing through this strategy that I've outlined. So as I said, the project was started 1 year ago, 1st October 22, and I think it's also important because it increases the visibility of certain type of research that is done here at the Faculty of Sciences, which may not be obvious to the community at large, to some colleagues, or to the local community, to students themselves. We have been pretty busy, and if you're welcome to visit our webpage, because we have been doing a lot of training events, exchanges, seminars, publications. So all this, you're invited to take a look and see what we have been doing. And basically, I think that I want to finish by saying that we have been doing many things, and we have all these ambitious, but our real business is to generate knowledge and to capacitate young students. And I think this is one of the most important contributions of this project, because through our activity, we are educating and training our students in an international mindset, using advanced methods, with the opportunity to attend training schools in top laboratories and to go and develop part of their work in top laboratories. And in fact, our students are our greatest asset, and being in a teaching faculty which excels in science, I think this is the great value. We have excellent students, and we have to match our research and research opportunities so that our students can move on into this field as well. I think this is maybe the most impactful outcome of this project. So you're all invited to follow us on social media. We do it because it's fun and because the European Commission really asks us to do that. So please follow us on LinkedIn and on X or Twitter or whatever. And I'll be glad to discuss this project, any details or activities later on. And I would like to thank you for your attention.
Thank you, Professor Claudio. And it is now the time for Carlota Coloni from IBEB to share with us another hot topic. She will help us navigate the neuroscientific landscape of sexual objectification and its societal implications. So let me put your presentation here. There it is.
Okay, so thanks everyone. So I'm a little bit afraid because this presentation is really different from what you heard so far. So I hope I will not shock you, at least surprise you a bit. I hope I will introduce you to the world of sexual objectification with the best clarity that I'm capable of. So I will just start by refreshing your memory about how women can be portrayed in the media. So this is a concept that you are all familiar with. It's just a matter of understanding how we study it, how we quantify it. So here you see some examples. And those are real advertisement, real picture that has been displayed in journals, social media, television, everywhere. So what you can notice is just an extreme focus on the body of women, with basically no attention to the face or their personality, right? And I also have an example of how women can be objectified here in Portugal. They can become a pastel de nata, so something that we all love, but it's something that is a little bit surprising as well, right? So obviously this phenomenon has been studied and has been theorized by Fredrickson and Roberts in 1997. And basically, they posit that women, when objectified, because it's not always that women are objectified, but when objectified, they are treated only as bodies that are that exist for the use and pleasures of other people. So this is specifically true in the Western society, our society, in which media and artwork tend to portray women with this emphasis on their body, as if their bodies were able of representing them, and only those. Obviously, this phenomenon can be studied from two perspectives. One is the perspective of the objectified person. Let me see, I can see. And the other perspective is the perspective of the person who objectified the other people. And the second is the focus of my work. So what are the consequences of the objectification that has been studied so far? So basically, we notice that when a person, and specifically women, are objectified, we have a decrease of the attribution of mind for them. So we believe that they have less mental capacity. Another thing is that they are perceived as having less agency, so the ability of acting in the world. And also there is an increase of dehumanization. So they are considered as being less human and more similar to objects or animals. So the first attempt of studying this phenomenon in a scientific way, so operationalizing it, was through the use of the inversion effect. What is the inversion effect? So we know that when we perceive a face, we all know this face, right? So we know that there are always some configurations that we are familiar with. So we know that the eyes are always on top of the nose, and the nose are always above the mouth, right? So we are able of perceiving the face through the relationship between these elements. But what happens when we invert this image? This relationship, this configuration are disrupted. And this goes together with a drop in the accuracy of recognizing the face. So usually we recognize face and bodies with a configural processing, while objects are recognized through an analytical processing. So we don't base ourselves in the recognition on the configuration between the parts, but just on the present or absence of certain elements. So this inversion effect has been used in the sexual objectification theory to test if women were perceived as objects and not as humans. So you see here, when sexualized male were presented upside down, so in the inverted position, there is a drop in the accuracy of the recognition. So we can say that they are perceived in a configural way, and so as the majority of faces and human beings. While the same is not true for the sexualized women, where there is no such a drop of accuracy, or at least it's not significant. And so we can claim, or at least Bernard in 2012 claimed, that sexualized women are perceived like objects. Obviously, this was just the first attempt of approaching this topic in a scientific way. This first study had a lot of missing things. They did not have a control. So a lot of other papers were published later trying to make sense of what was observed initially, right? So the conclusion was that even though we can find some mediating and moderating features, still the sexualized inversion effect exists and is present. So from a neuroscientific point of view, so this was just a behavioral study, right? Let's say that there are three major questions that we can answer, or at least I was interested in understanding. So one of these questions is like, how do we see these women, like visually, from a visual point of view? And how do we feel about them? And later, how do we behave toward them? So to answer the first question, we ran a study on the visual perception bias. It was an EEG study, and we used another paradigm, which is called the oddball paradigm. So basically, in this paradigm, we present a series of frequent stimuli, frequent, and all of a sudden there is an infrequent stimulus. I'm pretty sure you are not able to understand why the stimulus is infrequent from there, but this is a doll-like avatar, so it's different from the other pictures because it's the avatar version of the same human bodies that you see there. You're gonna see another picture a little bit soon. Later. So basically what happened, that when our brain processes this frequent, then infrequent stimulus, when it processes the infrequent, there is an evoke-related potential that is called the P300 that arise. And so the extension of the amplitude of the P300 grows as much as the infrequent stimulus is perceived as different from the frequent one. So what we did was to test the same hypothesis, right? So to test if the infrequent stimulus, which is a doll-like female avatar, generate a P300 that is different from the one generated from the male doll-like avatar. So we are looking at the comparison between these P300 here. And in the zoom, you can see that the doll-like male avatar is actually bigger than the female one, okay? So the meaning of this is that the male version is really perceived as different, while the doll female avatar is perceived as similar to the real humans. So we thought, okay, this is true for the sexualized images, right? So here we have pictures of women and men in bikinis, in swimsuit, but what happens if we test the same in a non-sexualized sample of images? So we repeat the same experiment, and basically what you see here is that there is no more difference between the two. So there is no more bias, visual bias in perceiving them when they are non-sexualized. And so we can conclude that the objectification of women from a visual perception, a visual point of view, is not just a metaphor, it's also clear visual bias. So we said, okay, we are actually able to understand at a certain point that these avatars are actually different from the real human, right? But at which point are we able to make this discrimination? So we ran a categorization conflict experiment with a technique which is really, really simple. And we used the mouse tracker. So we had to categorize each of those images that I show you into two labels. So if we ask the participant if they perceive them as object or as person, really simple. So we see here that when, this is the graph for the mouse trajectory for all the sexualized images, female images. So you see that there is an initial tendency of going into the object category, right? But then they pause, and then they change towards the right one, so the person. So in this way, we were able to identify the timings and the path that they follow, and we all follow, when we have to categorize these kind of images. So the next question was, like, how do we feel about them? Are we able to empathize with them? And so we ran a study on the empathy for affective touch. So we all know what is empathy, more or less, but scientifically, what we define as empathy is the act of representing and sharing the affective state of another person. And there is this simulation theory that posits that when we have to judge how the other person is feeling, we use our body internal representation of what we felt somehow in the past in order, and we reactivate that in order to understand how the other person is feeling. So we use that to test for the first time with real models in the room with us, how our participants were feeling, were empathizing with them. And the operationalization of this empathy was the calculation of the self-other overlap, which is an index of how much my feelings, my emotion are close to the one that I'm judging. So sexualized or unknown-sexualized women, and we add also the control condition of a mannequin, which is an object, clearly. Sexualized because it's completely naked, but still an object. So what we conclude from that was that our participants felt really, really in tune with the emotion of the non-sexualized women. Obviously, really far from the one of the mannequin, but the sexualized women are not perceived as having the same emotion of our participant or of the non-sexualized women, but more similar to the mannequin one. So another time, we are proving that women, when sexualized, are perceived more like objects than like humans. So we wanted to see if this was also, we could extend this concept of reduced empathy also in another context, which was the context of empathy for social exclusion, which is the most studied paradigm for empathy. So usually what they use in literature, what has been used so far was a cyberball game. So you see here this vignette of people tossing the balls, so the game that we all play when we were young, but we can still play, obviously. But in this game, some of the players can be excluded from the game or included in the game. And usually we have high empathy for the people which are excluded from the game. So what we did was obviously change these vignettes here and make them a little bit more ecologically valid. So we record videos of real people, so our models, playing the game and being excluded or included in the game. So this was an fMRI study, and what we found was the same pattern. So a reduced empathy towards the sexualized women, both at the behavioral but also at a neural level. So these are just the empathy network, which is more activated when we witness the exclusion of a non-sexualized woman. So the last question was, okay, we know that we have a bias in perceiving these women visually. We know that we solve this categorization at a certain point, but we still have a diminished empathy towards them. So what happened to our behavior when we have to interact with them? Because so far we were just witnessing their interaction in the world, but not interacting with them. So for the last question, we ran an experiment, an EEG study here at the University of Lisbon, where we ask our participants to play a game, an economic game, which is the prisoner's dilemma, with sexualized or non-sexualized women. So we not only did that, but we also administered a nasal spray, which can contain a substance called oxytocin. Oxytocin is a neurohormone that we all have, and it has been associated with a prosocial effect. So what we were doing was just testing if our participants were competing or cooperating more according to the kind of opponent that they were facing in the game. So at every trial, they could compete or cooperate, and they could gain money waiting for the reply of the opponent. So really in summary, what we found was that the oxytocin was able to increase the cooperation frequency for both the opponent, a little bit more for the sexualized than for the non-sexualized, but still it had a prosocial effect for both. But what was interesting was that it was evident for the defection choice frequency So we had a drop of 44% of the defection choice due to the oxytocin intake. So basically with this, and this study was also, this behavioral effect were also confirmed at a neural level with the P300. Again, it was an EEG study, too complex to describe now. But the main concept here is that, so we know that women's sexualization influence the social decision, and we proved them at the behavioral and the neural level. And so the effect of the sexualization is that it impairs the cooperative behaviors towards the sexualized women, but likely the oxytocin seems to have a nice effect here, so seems to diminish these negative consequences of the sexualization. And what we did after is what actually we are doing currently, is a project that has been, is a PEX project funded by FCT, which we decided to test not only the behavior towards the sexualized and non-sexualized women, but also test the aggressive behavior towards them. And we did that, and we are doing this, also combining the effect of the oxytocin, but also the testosterone. So two molecules that are supposedly having separate effects in our brain. And this is the first time that something like this has been done. So we are really proud of it, but the data collection is still ongoing. So if people here in the audience wants to participate to the study, please don't, because now you're spoiled. You know everything, so don't register, please. So I just want to finish with a take-home message. So because it's nice presenting all this research, all this data, all this number, but then like what can we do with this insight? So I think that I show you enough evidence to convince you that the sexualization bias is real. We all experience that, and we experience that as women and as men. No gender is out of the picture here. So I think that whenever you're going to be in a social interaction, it's gonna be at the cafeteria, it's gonna be at your next lab meeting, in the metro, everywhere, what you can do is to be aware of the fact, remember what I presented you today, remember that you have a bias, we all have it. So you should challenge your bias, you should pause and remember that every person deserves respect, and we can, with empathy and understanding the other's perspective, try to break the cycle and try to diminish the negative consequences of this sexualization bias. I will just thank all the people working with me closely in this last experiment that are actually testing now in the lab, and obviously all of you for your attention.
Thank you, Carlota. And now we will welcome Professor Barbara Anes from CQE to share with us ChemBio Services for Research and Society. So put your presentation.
Good afternoon. My name is Bárbara Velasco Anes. I have a bachelor degree in chemical engineering, and I studied here at Ciências, where I did my master degree and my PhD degree in analytical chemistry. I was hired in the beginning of this year as a specialist on laboratory and computer infrastructures to start a new project here at Centro de Química Estrutural at Ciências. The aim is to implement the facilities at Centro de Química Estrutural, the now called ChemBio Services facilities. The objective is to provide equipment and services to students, researchers, companies, industries that are interested in using it. And so the main objective is really to providing and offering this possibility of using these already existing equipments without the need of the other researchers to involve in large investments and without the duplicacy of these equipments. This model is already implemented in the several institutions and here are now available at Centro de Química Estrutural here at FCUL. So if I can resume the information, the CMAFcIO Services Facility integrates the multiple scientific research laboratories whose instrumental infrastructures are available to provide research support services beyond the Centro de Química Estrutural and the Ciências Universe. This project started on the 17th of January of this year. It involves now 8 facilities. 2 of them already are available to you if you want. They are collected in 15 laboratories involving more than 50 equipments. It was a very interesting and engaging start. The process part was to think how to do it and to put all this together. It was a very well thought procedure, and some of these steps led to the implementation of 2 of the new infrastructures that we have and that I want to present you here. Sorry. So the first one already available is the atomic force microscopy facility, which goal is to provide sample measurement analysis. The atomic force microscope is a scientific equipment very well known, is transversal to many areas important to nanoscience, with applications in the field of chemistry, biochemistry, biology, geology, electronics, material science, pharmacy, dental medicine, and energy. So here are some of the applications, and we can work with polymeric films, characterization of metallic polymeric nanoparticles, DNA interaction studies, and biofilm formation. This important equipment studies the surface of these materials and can be very useful to complement research projects in these areas. Another facility that we have now available is the cell culture and flow cytometry, which available services is to provide the researcher access to equipment. We have now 9 equipments on these infrastructures. We have the Type 2B biosafety cabinet, a CO2 incubator, inverted phase contrast microscope, and a flow cytometer. In our flow cytometer, we already have some external users using this equipment. Currently, our priority is to certify our equipments to make them fulfill the requirements of the confined use of genetic modified organisms. And so if any in the audience are working with the areas of biochemistry, biology, medicinal chemistry, toxicology, immunology, hematology, or cancer research, you may find some important equipments here if you want. Here are some of the applications of our facility, and beyond these 2, we are planning to be available soon other facilities that involves the calorimetry and thermal analysis, gas conversion, thermophysical properties, fluorescence and biofluorescence, surface area analyzer, and we also have an ultracentrifuge. All these facilities already have these equipments available, and we recently bought 2 new equipments, dynamic light scattering, is an important equipment to the characterization of metal and polymeric nanoparticles, such as lipoforms also. And we acquired also a high sensitivity FTIR. So to promote all of our infrastructures, our facilities, I designed a website who is now available at this link, and that also you can scan it on this QR code. In our website, you can discover our infrastructures, the ones that I mentioned about, and they are already available, and those who are still to come. Exploring our website, you will find all of the list of the equipments available, also our location and contacts, and if you need some information, you can access to our contact form. Inside the website, you can find detailed information about each of the new facilities that already are available, and where we can present also some papers that we're publishing regarding each of these facilities. During this process of implementation, one of the important paths of the organization was to apply an online booking platform, very important to concede the researchers access to our equipments. So we choose an online booking platform that is really easy to use, is a very simple and intuitive platform, which combine detailed information about all equipments, guidelines, protocols, and safety procedures. Here you can find an example of the information that we have on our booking platform. And so using this application, we have updated information about our users, our equipment features, manuals, procedures, booking rules. We have also information regarding the security and waste management rules, recording, maintenance, cleaning, usage rules, and with all this information, we can actually have like some kind of equipment knowledge center when we centralize the procedures, and we guarantee that we have all the history of what is happening with our equipment, without losing the history part that comes across with sometimes the rotativity of our students in our lab. Here is an example of our procedures, and also to organize this implementation process, it was detected that an important part was the communication, to assure the communication between all the users. So we established a system of communication that we call the EPE, the Infrastructure's Practical Information. We came across at our facilities between all users using this line of communication. We perform announcements regarding procedures, regarding waste management rules and safety as well. We perform these documents in a very clear and well-structured, well-thinking way, using as much as possible graphical information to be as clear as possible to all the users. And here you can find an example as well. We have now 8 informations regarding our facilities, and with the need, we expect much to come. Also, one of the things that we detected was to guarantee the access of our laboratories only to authorized users. And so it was the need of implementing a new simplified and more controlled access to our laboratories with a safer access. To do that, we installed a padlock with the safety codes for algorithms, and all the authorized users are given access to that code, and this way there are no more lost keys or someone who forgot their keys, and everyone who is authorized can have facilitated access to the laboratories, and we have now a more controlled way to know and who have access at all time to our lab and equipments. Another aspect that we felt was the need for the reinforcement of the importance of complying with safety rules. So we have to optimizing those information producing these posters that are more visual, and the aim is to complement the information with the particular aspects of each of our facilities right now. So the main purpose of the CMAFcIO services facility is to create and enhance the research, not only at Centro de Química Estrutural, but also at Ciências and beyond the Centro de Química Estrutural and Ciências. We hope and wish that with this new facility, we hope to develop new ideas and enrich the projects within the community of our students and researchers, and also, of course, to promote the collaboration, making the equipments available to a community that goes beyond the immediate users. Outside, you may find our poster, where is our contacts and detailed information that you can scan as also. And if possible, and if you want it so, you can scan and take a look at our website, and maybe you will find new ideas to improve and enrich your research. So I want to thank you very much for the possibility of presenting the CMAFcIO services facility, and I'm available for any questions that you want. Thank you.
Thank you. Thank you, Professor Barbara. Let me switch the presentation here real quick. Okay. So before we take a well-deserved break after so many interesting communications, let's meet another Ciências researcher that is working on the global challenges that we have discussed this morning.
Eu trabalho em duas áreas, na verdade, em que a primeira é a aprendizagem automática, que consiste num conjunto de métodos que aprendem a resolver problemas com base em exemplos. E a outra área é onde eu aplico estes métodos. Os métodos que eu uso são muito engraçados porque são inspirados na natureza, na evolução e na seleção natural de Darwin. E a área onde eu os aplico é a monitorização florestal com imagens de satélite. E isto é engraçado porque há aqui um ciclo em que a natureza inspirou um método que agora ajuda a natureza. A monitorização florestal é essencial para implementar os programas de desenvolvimento sustentável das Nações Unidas. Todos sabemos que a perda de florestas implica perda de biodiversidade e mais emissões de CO2 para a atmosfera. E os meus algoritmos ajudam, tornando esta monitorização mais automática e mais fiável.
Thank you. Thank you, Professor Sara. We will surely continue to discuss these challenges brought by the rise of artificial intelligence in the near future. And it is now time to have a pause, to have a snack, and to chat with your colleagues with the ideas that might be sparking in your brain with all these communications. And we meet here again at 4:45, please. Thank you. So welcome again. Let's start our last session of today, but first of all, let's reflect once again on the global challenges that we, as a society, are facing and we will continue to face.
A minha investigação consiste no desenvolvimento de redes neuronais para a análise de imagens e vídeos. A grande vantagem destes modelos é que aprendem diretamente dos dados e são flexíveis quanto ao tipo de dados que processam e quanto ao tipo de tarefa que aprendem a executar. Por este motivo, podem ser aplicados desde a imagens biomédicas a imagens aéreas adquiridas por drones. Para além deste lado mais aplicacional, estes modelos permitem o avanço do conhecimento científico ao analisar e descobrir padrões em milhões de dados e, assim, extrapolar novas ideias e novas conclusões.
Hi, everybody.
Sorry. Thank you, Professor Nuno. This last testimony of today and the testimonies that you have heard during all the sessions of today are just a few of the several researchers that we have here at the Faculty of Sciences and that could be invited to share their expertise and their work with us. And perhaps they will be invited in the future for other initiatives. We never know. And so at Ciências, as you know, we are committed with acting today for a better tomorrow. And for the last session of today, we will be talking about communicating science. But before we dive into science communication, we will start by hearing success stories of some Ciências alumni. And we will start with Nuno André da Silva from Grupo Luz Saúde. Unfortunately, due to an unforeseen event, Nuno could not be here physically today, but he wanted to share his testimony with us in a video.
Hi everybody, my name is Nuno and I'm a former student from the faculty. I was part of the first cohort in biomedical engineering biophysics, and currently I'm head of data science and innovation at Hospital de Luz Laranguels at Luz Saúde. So when you're talking about the impact of the faculty in my career, I would split it in two main components. So the first one related with the enthusiasm. So when I started the faculty, I was not sure that I wanted to pursue this course. It was new, didn't know much about it. But I think it was in the second week of classes, I had the opportunity to have a class with Professor Douglas Soares. The enthusiasm that he put on explaining how the X-ray works, for me, it was kind of key moment, and that from that moment on, I was convinced that I wanted to do the biomedical engineering because it combined physics and medicines. The enthusiasm that the professors put in the classes, that's something that impacted me, and I try to keep with me also in everything that I do, so put passion on what I do, and I learn it from the faculty. So the second component is related with the critical thinking, like thinking different and try to push the boundaries. So since the beginning of the course, I had the opportunity to contact closely with multiple research projects. So I had the opportunity to have an initiated grant for research with Professor Luís Peralta. Then, I think this is one in the second year. In the third year, we had the opportunity to go abroad to do a small project. So I went to Amsterdam, came back, did the master thesis. And then in the final year for the master thesis, actually, I went abroad through the contact from Professor Pedro Almeida to Germany, where I did my master's, where I finished the master thesis. Yeah, so during the whole course of the university, I had contact with research, good way of doing research that allowed me to build a strong basis that made me confident that I could do a PhD abroad. That was the second step in my career. So yeah, so the faculty gave me the tools that I needed to think critically, independently, and in a structured way. And that's something that I learned from the faculty, using the PhD, and I use in every day, in the day-to-day, because in such an uncertain world with so many things happening at the same time, we need to have a scientific mindset if you want to be coherent in your decisions. So because you need to be able to identify the problem, analyze the problem, make hypotheses, and then take decisions and validate your assumptions. So that's something that I learned from the faculty, and this think like a scientist, I would say, it's key also for my pathway and for the way that I think. So regarding the future, so as a former student, I try to keep engaged with the faculty. We receive some master students to work with us, to do their projects, also to contribute back to the faculty, because it was very important for my career that we also want to contribute for the development of the faculty students. So in a nutshell is this. I apologize that I couldn't be with you, but maybe next time, and I hope you have a great session. Bye-bye.
Well, thank you, Nuno, and surely in the next opportunity he will be here with us. And now we will welcome on stage Professor Tiago Marques from the University of St. Andrews and from COL, and also a former student from Ciências ULisboa. Let me put your presentation here. Very colorful.
Thank you, Martha. Thank you, everyone. Let's see if this works. It works. Okay. So, usually I speak on improvise, but today I'm going to read because I think the words matter. Good afternoon, Ciências. Thanks for inviting me to be here. This is not an easy talk for me. It's the irony of an imposter syndrome having to talk about himself as a success story. Nonsense. Worst, no one really wants to hear success stories. What does success even mean? Unlike beliefs unfamiliar to those unfamiliar with survivorship bias, success was for me as often as it is for others, just a bit of privilege and being at the same time in the same place where good things were happening. Those are the things that brought me to you today. And given today's context, I'll spare you times BC, that's before Ciências. Preparing this talk, I looked at my photos for inspiration, and it's through them that I share my luck with you today. I entered the same room at Ciências a millennium ago, a random draw of a coin that could face many possibilities. The actual coin ended the wrong way, but the hunch led me to be here. And little would I know that would shape my life forever. It's 1993, and I'm standing there on the chairs you sit today, and an amazing dozen colleagues become an outstanding story of mutualism among friends, a group of students studying together over shared notes, giving them a strong competitive advantage. What we achieved as a group is remarkable. We could fill a book with it. In fact, we have filled several. Luck earned me money in the second year when I was in a class by Dinis Pestana, and he showed me the dark side. He showed me, and I found my home, my research home at COL. Serendipity later, I found a thesis in his office. It was Russell's Alpizar Jara's master thesis on a topic that would become my PhD. Russell was there, provided guidance, but I only finished my master's because there was a young mathematician, Silvio Velosa, which would, after each class, patiently explain me what the hell those Greek letters were supposed to be doing. It was not easy. Russell would later encourage me to go to St. Andrews. He said, you should go and do a PhD with Steve Buckland. That was as nonsense as learning mess from the Pope, and I messed it. Anyway, I went to St. Andrews. I met Steve, funded by my grandmother, which if I had to say everything she did for me, there would be a speech just for that. Lucky once, I arrived in St. Andrews, and I realize now that I'm actually lost in my slides. But that's not a problem, because errors are part of living, right? Why is this not working? Yeah, I just forgot to keep passing the slides. Okay, here we are. You just lose the pictures, okay? Sorry for that. Lucky once, I arrived in St. Andrews at the same time as a lecturer, young lecturer, Kiwi lecturer, Monique Mackenzie, and her husband that would arrive a few months later. Serendipity, Monique is today St. Andrews Vice Dean, but more importantly, they became my foster family in the UK. I was lucky twice when I shared a house with Charles Paxton, who taught me how to think about science, and I was a third time lucky when I shared my office during my PhD with Eric Rackstead and Len Thomas, which both shaped who I would become. I embraced cream and became a criminal. It's an inside joke. Fast forward 4 long years, I returned home to my son, Philippe, being born the same week as my Viva, and so I can't stay in St. Andrews. Len told me, you should do teleworking, inventing the word, because it didn't exist at the time. And Philippe was born, and so was a project, DCAF, an innovative project, to use the word, where we were estimating animals using passive acoustic, the sounds they make. It sounds like these. This is a sperm whale. This is a sperm whale looking for food. Since then, I've counted sperm whales, I've counted polar bears, I've counted gibbons, you name it, and I will count the thing that you come to me with tomorrow, if that happens. Well, bad luck struck a couple of years later. Louisa, a biology colleague, 15 years partner, my son's mum, someone of you once knew, was hit by a car, a drunk driver, a son of a bitch, sorry, and got crippled for life. Many lives changed forever. A controlled experience providing you compelling evidence that luck is key. She was better than me, but she never succeeded. I faced depression, burnout 3 times. Some events can't be overcome without losing some of your own humanity. We all must take care of ourselves. I talk openly about mental health to anyone who wants to hear. I'm on antidepressants, likely for life. It does not define me, but it's who I am. I overcame the darkest of moments with an amazing support network. I spent 1 year not working, and the only question I would hear was, how do you feel? And I was getting paid for it. Thank you, Len, for that, for believing in me. Any success that I have is yours too. Lucky again, as Henrique Cabral, who was a teacher here teaching Ecologia Numérica and Modulação Ecológica, asked me if I wanted to fill in for his shoes as he was going abroad. It was just a year, so I said yes. A year turned 2, then became 6. Still counting, and it will continue so until my students stop giving me an award each year for best teacher. That's something I'm proud of. I've lived and breathed Ciências, as you can tell, across 3 departments. First, biology and stats as a student, then maths, stats, and biology as a teacher. Full circle biology as a teacher. Here I've learned nothing gives me more pleasure than the look in the eyes of a student that finally gets it after the 7th time I'm explaining what those Greek letters are that I'm now supposed to demystify somehow. There they are. Well, what have I learned so far? When it comes to work, I try to give, share, collaborate, provide, facilitate all that I can without thinking what's in it for me. I've said and done things that could kill several careers. There's some witnesses here today of that, in fact. Some of them, again, stories for another day. Said I'm sorry when I thought I had been wrong, said yes to way too many things. Saying no to things is something I still haven't figured out how to do, as you'll find out when tomorrow you come to ask me to look at your data. For the younger here, searching for inspiration for their own successes, I wish you, above all, luck. But don't make the mistake of waiting for it to come to you. Work hard and be ready to find yours. If you're here, if you're Ciências, you have what it takes to make it. Believe in yourself. I never did, but it never mattered. Ciências gave you enough to succeed anywhere, provided you match the effort giving yourself to it. Find the best place in the world to do what you want to do, go there and do it. And in the way, help as many people as you can. Nothing of you, what you accomplish, will mean anything if you have no one to share it with. I'm afraid life is meaningless, but you can actually your life can have a meaning. It's up to you to find out what it is. Decide what's yours. I looked at photos for inspiration. You got a glimpse of them. If you are lucky as I have been, hope not to jinx it by saying it out loud here. Once you look back, you can say, damn, boy, nailed it, because I had the privilege to see the Arctic before it melts forever. I counted polar bears in the Barents Sea. I counted whales in Greenland. I water skied in between. Taught classes at Disney World, kissed a whale in Hawaii, watched many times U2 live, even touched Bono's hand, gambled in Las Vegas, jumped into frozen lakes in Canada, got held at gunpoint by Prince William's security detail, been to where movies were made, even took a selfie with Marcelo, but who hasn't, right? Well, if you are lucky as I have been, you will find a place to work with great colleagues that support and encourage you, always ready for fun. Work hard, but be sure to party harder, okay? That's fundamental. And never, ever take yourself too seriously. If you are lucky as me, you will have the best students with whom I will learn from and I have learned from. You will have students turn friends and friends turn colleagues. I got to see my son being born, his first soccer game, his first day at school, to be present when he shared with me the best, but unfortunately also the worst of news. I had several partners whom I've loved, and hopefully they've loved me back. They said I did. Students, if you are as lucky as me, you will have had colleagues turn friends and friends turn family. If you are as lucky as I have been, you'll have been cared for. If you are lucky as I was, you are certainly headed for success. May you find here in Ciências, as I did, the inspiration to do so. Thank you.
Thank you, Professor Tiago. Thank you, Tiago. What an inspiring talk. And now let me switch again here for our presentation, because we are reaching one, I hope, also very awaited moment of today's session, which is the final of the second edition of the initiative Picture Science, Boosting Sustainable Development Goals, in which we invited current PhD and master students of Ciências to share with us how their research addresses sustainable development goals through a 3-minute video. Before we start, I'm just going to ask our first speaker, Patricia, to join our colleagues here because she will have a microphone. And also, who are our 3 finalists here? Can you please wave at me so I can see where you are? 1, 2. Can you please come here to this side of the stage, please? Here. Thank you. And we are missing a 3rd finalist. It's there. Please meet us here. Okay, so we have received several high-quality applications from diverse scientific areas, and this makes us very proud. Congratulations to all the participants for having had the courage and the commitment to apply. And all of you, the participants, will have the opportunity to attend a science communication workshop soon. And to open this moment, I will call to stage someone that has been through a similar experience recently with amazing results and of whom we are all proud of, Patricia Chaves from C3C. Patricia has applied to the first edition of the competition 3-minute thesis held at the University of Lisbon. And in that competition, participants were challenged to present their research in a 3-minute pitch. Sounds familiar, right? And Patricia was not only selected to the final, but she scored 2nd place. So, Patricia, you are ready to share your experience with us? Almost ready. So, the floor is yours, and I'm going to put your slide here. So let's see what Patricia has to share with us about her experience.
Su, su, ha, ha. These are the sounds you'll hear if you ever walk through the rice fields of Guinea-Bissau. And if you look closely, you'll see that it's actually women shouting to scare away wildlife. Women that, with waist-deep water and bare feet, cultivate rice. I had the huge privilege of walking behind them, and today I invite you to take this journey with me. Together, we'll be able to see the birds that they're trying to scare away, using cassette tapes that with light act as a barrier, and scarecrows that I guarantee will work with us as well. You'll be able to see insects that bode a bad harvest, and frogs that they fear, but at the same time bring rain at the onset of the rice season. You'll hear about bats and how they eat their beloved mangoes, but also about their contribution by fertilizing their fields and their gardens. Rice is consumed by 3.5 billion people worldwide, and in West Africa, it's the main source of food. In Guinea-Bissau, families produce rice for their own consumption. And often they face shortages throughout the year. It is within this context of food insecurity that my PhD research took shape, with the aim of working towards wildlife conservation by enhancing their agriculture contribution. Now, when I mention contribution, this is what I mean. Bats devour thousands of insects per night. And if you think about it, usually birds and monkeys that are bigger and more visible animals are often accused of damaging crops. But we know that insects pose major threats to agriculture. Just to give you an example, in the United States, the service that bats provide by controlling pests saves the country a staggering $3 billion. Can you imagine that? It's insane. And it's considering this potential that I have been in the field for the past 2 years interviewing female farmers, because I want to know how they relate to wildlife, what they think about these animals, and what they do to protect their crops. At the same time, I also want to uncover which bats and birds are using the rice fields. And to do so, I've been conducting surveys, counting birds, seeing how they use the landscape. For bats, because I cannot see them as easily, I have been using devices to record their sounds, through which I can identify if they're passing through, if they're socializing like we are right now, well, more or less, or more importantly, if they're hunting. But these methods do not give us the most important information that I hope you all are curious about. Who's eating what? And to do this, to understand this, we have been using nets to capture both bats and birds, and later release them, obviously, collecting their feces in the process and identifying the insects they're preying on. So with all of this information, I intend to build a network that will illustrate how wildlife is interacting in the rice fields, who's munching on who, and build an approach that creates an environment where humans benefit from the presence of these animals and therefore protect them. I'm going to go back a little bit now. So this was actually my pitch for the 3-minute thesis, and I wanted to share it with you. It's completely different saying it in English and in Portuguese. And today I was invited to talk a little bit about how this science communication obsession came to be. As a child, I was a very talkative little devil, and I think I drove my parents insane to a point that they enrolled me in every activity they could think of where I could burn all of my energy. So I basically did theater, and I was competing in poetry slams. I'm highlighting these two activities because they highly contributed to help me as a scientist with aspects of communication that I struggle with. And the major one is that facts are not always enough. To reach an audience, we need to be able to capture people's attention, to connect, and to allow space for participation. And sometimes scientific jargon and method help do the opposite. I think as scientists, we appreciate structure, and we have a hard time simplifying concepts and using real-life analogies, and maybe even memes, because we believe that takes something away from our research, but actually it brings people into it. And well, I struggle with structure, and I had an experience as a museum educator in an exhibition about science. And that really helped me deal with the blocks I have, because I was used to, as a scientist, to first do a pretty introduction and then talk about my methodology and then talk about my results. But with museums and communicating as an educator, I realized pretty on the onset of those visits that if I communicated results and real-life impacts at the beginning, people would be much more interested in the process for the rest of the visit. Not only that, but that storytelling is such a major tool that actually humanizes us as scientists and brings trust to the scientific process. So I was communicating to these different audiences from different age groups. The VIPs were the hardest part for me. And I realized that in all of these groups, there was a common theme. People would be much more interested in the science that I was communicating if I was as eager to listen to what they had to say about it. So one thing that for me is super important when you are communicating, even if you feel like it's a one-way streak, it's not. And curiosity helps bridge the audience and the speaker. Now, I want to bring you back a little bit to my PhD experience, where I had the privilege of working with these wonderful female farmers. They farm rice, which is a really heavy job. They cook for their families. They take care of everything. Men contribute by paying for stuff. And these women, they answered my questions patiently. I did interviews and focus groups for like 3 hours straight. And in that experience, I feel like they didn't know they were impacting me so much. Not only about how I feel about science, but also like about preconceived notions I had about life and everything else. And through this experience, the main thing that stood out for me was that I cannot envision conservation without people. And more importantly, I felt like I was as passionate about science as I was of translating science into these conversations and connections. I also became really feral about communicating outside of my peer comfort zone. I believe that communicating science should be a routine outside of this comfortable stage that we are on. And besides that, I also felt like by doing so, we'll be able to adapt our message to make it as universal as possible. So as we are talking to different audiences, we're making our science more universal, because science should be for everyone. And I really believed it is. I was invited here because of the participation in the 3 minutes thesis, and now I want to extend that invitation to other PhD students that might be here. I'm sure there's going to be another one next year. I'm pretty sure about it. And it was such a great experience, because you're not only be dealing with other PhD students that are going through the same struggles and peaks of your PhD journey, but you're going to be in close contact with science communicators that will greatly benefit you, not only relating to the structure and the blocks you have like I did, but also they will make you reach your potential. It's an experience that greatly rewards passion. And I believe passion, it's like the icing and the cherry on top. I think every great communication is just as strong as the passion, the belief, and the delivery of the speaker. So I hope next year Ciências is there strongly and cohesively. I want to go off stage by wishing good luck to the competitors of Picture Science today. I'm really excited to hear about the work that you've been doing. And I want to let you in on a little secret that I think I've probably made too obvious. People were and are the best part of my PhD journey. And I think about science. And those conversations that I have with female farmers about ecology, about life, about ecosystems, actually change, I believe, the course of my career. Thank you.
Congratulations, Patricia. This is very inspiring. It was great to hear your sharing, and I hope it has inspired our participants of the second edition of the Picture Science. And so it is now time to watch the communications of our 3 finalists that started by submitting their communications in video format, and the decision to choose the 3 finalists was difficult for all the great reasons. And now I will start, this is just by alphabetic order. I will start by calling to stage Inês Feliciano. You can start coming here. Inês is pursuing a PhD in physical chemistry. She's studying the energetics of multi-component crystals under the supervision of Professor Manuel Minas de Piedades and Professor Carlos Bernardo. I'm just going to put your slide there, and then I will tell you when you can start.
Okay, I don't know if you can actually, okay, you can hear me. Nice.
Yes. Okay. So just a little bit. Inês, here you are. Okay, whenever you're ready.
Okay, so hi, thank you for the introduction. My name is Inês Feliciano and I'm a PhD student. My work is about co-crystals, the name like multi-component crystals, a very huge name. And I'm here to show you how interesting co-crystals can be. To explain what co-crystals are, I'm using an example of the pill. The pill is a solid that is composed of the active medicine. And this active medicine is called API, and the API is a solid composed of molecules of the same compound. Co-crystals are when you have in the same solid two or more different molecules. In this case, I'll be using the API and the coformer. Coformer is normally choose from a list that is a list of compounds that is already recognized as safe from the World Health Organization and is actually cheap. So this combination, the API and the coformer, can adjust some properties that improve the effect of the API. So with co-crystals, we can actually redesign and create affordable medicines that can, recreate and redesign affordable medicines, since we are decreasing the amount of API use and increasing its effect. I'm using the example of the pharmaceuticals, but basically co-crystals can be used in any other field, like pesticides or even explosives. Okay, now we have a new compound, but we need to produce it. And how can we do this? One of the main concerns in chemistry is the amount of solvent used to produce these chemicals. To produce co-crystals, we are actually using a green method, mechanochemistry, where the two compounds, the coformer and the API, are grinded together like this, without any solvent, or if needed, would be the tiniest amount. So besides the solvent-free synthesis and, hold on, besides the solvent-free, the waste of this synthesis is nearly zero, and the efficiency is almost 100%. So it's a very good method to produce them. Okay, so we have a new chemical, we have a new system, but this type of compounds are actually very new, and they need to be studied a little bit harder and more. And my work is trying to understand some fundamental questions about these compounds. For example, if they are stable, so in the future they can be actually used and produced for anyone. Thank you.
Okay, thank you. Thank you very much, Inês. And it's now time for us to call our second finalist, João Sequeira. João is pursuing a PhD in biochemistry under the supervision of Professor Miguel Machuqueiro and Professor Adrian Reitberg. His thesis title is, and I'll try to say it correctly, a new AMBER CPHMD implementation to study the acid-sensing ion channels inhibition. We will certainly understand more with your pitch, right?
Right, for sure.
Okay, so let me put your slide here.
Thank you very much. Such a pretty slide. Okay.
Whenever you're ready.
Thank you very much for the introduction. Okay, I can now start my pitch, and hopefully you'll get a little bit of a better understanding of what I'm really doing. So starting, I want to talk to you about pain. Pain, it really hurts, right? And sometimes the pain just won't go away. Actually, studies have found that more than a third of the Portuguese adult population suffers from chronic pain. And this is almost unbelievable to think of, right? Look around you. And this, of course, has led to a widespread dependence on painkillers. A very common type of painkiller, of analgesic, that is often prescribed to people with moderate to severe pain are opioids. Opioids can be used even in the most extreme of cases, and morphine is a very good example of this. However, they are opioids, meaning that they're also incredibly addictive, and people tend to develop a relatively high tolerance to them. And here's food for thought. When someone's constantly in a lot of pain, they find it really difficult to fall asleep. So when they take painkillers, they just immediately fall asleep, as they're exhausted. And if you have to rely on painkillers to fall asleep, you can very easily understand how easy it is for people to get addicted to them. Also, when you take these opioid analgesics, you not only get the analgesic effect, you also get a very large dopamine release in your body, meaning that you get a very strong feel-good sensation. So you can see where the danger lies when it comes to these kinds of drugs. There are, of course, a lot of alternatives on the market that are not opioids and that you've likely heard of, like Xanax or ibuprofen. However, they're not as strong as their opioid counterparts, meaning that they cannot really be used in the most severe of cases. And so it appears that the dream would be to have a drug that is as strong as the opioid analgesics, but without having all of the effects, the negative effects that the opioids do. And this is what my PhD plan is all about. Just in line with Goal 3 of the Sustainable Development Goals, we want to ensure healthy lives, and we want to promote well-being for all at all ages. Here, at the Faculty of Sciences of the University of Lisbon, and more specifically, at the Computational Biophysics Lab, we use computers to study the smallest parts of life. And this allows us to understand diseases, to study diseases on a molecular level, which gives us a great advantage when it comes to discovering these new drugs. And to find these new alternatives to the opioids, we'll be focusing our attention on a family of proteins that is tightly related to the feeling of pain, which are the ASICs. Yes, just like the shoes, easy to remember. So before we can really simulate these proteins and understand how they work, we need to develop an extension to a computational method that was developed by my supervisor, Dr. Miguel Masqueiro. And after having this tool, we finally be able to simulate them and really get all the information we need to search for and hopefully find the so desired non-opioid analgesics. I hope I've sparked your interest in the research that we do, and if you have any further questions, please feel free to come see us anytime. Thank you very much.
Thank you. Thank you very much, João. He was our second finalist. We have a third finalist. I think I don't need to tell you to pay attention to all the pitches, but you need to pay special attention because it will be you who will be deciding the winner today. And I will be explaining to you in a little bit how you can decide who the winner will be. And they are now putting the microphone. Everything is okay. Okay, so now I will call our third finalist of the second edition of Picture Science. I'll call to stage Mariana Oliveira. She's pursuing the Master in Biomedical and Biophysics Engineering. She's working in the biofabrication of conductive materials for cardiac regeneration under the supervision of Professor Nuno Matella. I'm just going to put your slide there. Whenever you're ready.
Hi everyone, good afternoon. My name is Mariana and I am a Biomedical and Biophysics Engineering Master finalist. And today I would like to tell you a bit about what I do. So if it is true that we live in an increasingly unfair and uneven world, which unfortunately we do, then it is also a fact that mankind never had these many resources and opportunities to do actual good. In fact, in 2015, the United Nations established 17 essential goals that ought to be implemented by 2030 in order to ensure that every human being leads a healthy and dignifying life. For example, for its third goal, the United Nations wants global health and well-being. But by 2023, this goal is still far from being attained, as there are still several preventable diseases that yield high death rates and disability worldwide. For example, cardiovascular diseases. Together, they are responsible for 32% of all global deaths. They lead to heart failure and, in severe cases, to heart transplantation needs. Yet, we know that heart transplant is no viable solution as the demand for heart transplantation is consistently higher than any possible donor offer. And so, it is paramount that scientific areas like tissue engineering and biofabrication come together in action to create more sustainable alternatives. And this is where my line of research comes in. For my master's thesis, I developed materials that allow cardiac tissue engineering and regeneration. And because our adult cardiomyocytes, which are the cells in our heart's myocardium, do not self-renewal, and because current tissue engineering approaches lack cell maturity, I used conductive nanomaterials to promote this maturation by delivering physical and biological cues to cells. To further respect the United Nations goals number 12 and 13 that stand for responsible production and climate action, I chose to use, whenever possible, natural and more sustainable materials like alginate, which is a natural polymer derived from brown algae. This led to an inherent reduced carbon footprint, thus also contributing to goals 14 and 15 that stand for life above and underwater. Throughout my research, I developed alginate-based scaffolds and biowings with embedded conductive nanomaterials to allow cell bioprinting and cell seeding. And after many months of hard work and research, my results showed that these materials not only improved cell viability in cell culture experiments, as they also helped promoting cell maturation, which is key for these fields. And so, even though small, these results already configure a great starting point for research on this topic. And while contributing to goal number 9, they show that if we combine science, technology, and innovation together, we create the right path towards a better and more sustainable future. Thank you for your time.
Thank you. Thank you very much, Mariana. Thank you to all our 3 finalists. You are all, you should be congratulated because you were brave enough to come here to this stage and to present your research and to face all the nervousness to come here. So you are already being congratulated. So now the focus is not on you, you can breathe. Now the focus is on you, the audience. And it is you who will decide who is the winner. I see already many people snapping their smartphones, great. I was really going to tell you, please grab your smartphones, tablets, or laptops and go to www.menti.com and put that code, please. I'm going to switch slides now because the Mentimeter is not launched yet. So let me put it here. You will see it now. And so now you can submit your votes, and you should be seeing the voting question on the screen, and the code is there, just up there. And which communication sparked your curiosity more? Which one you found was clearer? And which one did you consider that addressed better the Sustainable Development Goals? And not only scientific rigor, but also the quality of the communication were the criteria that we applied to select the finalists and the criteria that we invite you to use to also select our winner today. And it is on purpose that you are not seeing the columns yet rising, because we are going to only to reveal it in the end. So has everyone voted already? Is anyone finding any difficulties? I see just people saying yes. So I think everyone has voted. So it's time for the big announcement for us to know. Let's hope this works. We have 46 votes here. So let's wait and see who the winner is. Aha, Mariana. Congratulations, Mariana. I invite not only Mariana, but the 3 finalists to come here, please. And Professor Pedro Almeida to give the awards, please. And maybe we can come to all over.
Smartwatch for you to have fun with and to time your communications for the next time. Okay? Congratulations. Thank you very much for joining. And for you, unfortunately, no clock. But thank you very much. And the usual stuff. It was a pleasure having you, and I hope you've enjoyed it.
And now a group photo. Congratulations once again, and thank you for taking the risk and coming here and applying. So I hope you will enjoy it and learn a little bit more with these communications. And now we are reaching to the end of today's full and rich program. Let me just kindly ask Cissé, the sound here. Can you please ask Cissé? The sound here, please. Thank you. I would like to ask first a round of applause for all our invited speakers and congratulate them for their work. Also, do not forget that we are celebrating the Ciências Research and Innovation Week, not just the day. And the week will be plenty of activities on diverse scientific areas. And please check our website for all the program, the activities that will take place in the next few days. And now to wrap up today's event, I will invite to the stage Professor Pedro Almeida again, and our Vice Dean for External Relations and Image.
Well, good afternoon, everyone. Dear colleagues, ladies and gentlemen, distinguished guests, researchers, innovators of today and of tomorrow. After what we've seen today, and its extraordinary quality once again, it is both a pleasure and an honor to deliver the closing words of this Ciências Research and Innovation Day. I want to start by asking you to give a big round of applause to our colleague, Professor Margarida Santos-Reis. She's a mentor of this day and an organizer, so please join your hands for her. And I want also to stress my profound admiration for the Department of Communication and Imaging, and especially to Marta, because she was, even though sick, of a tremendous help putting together all these events. So I also think that she deserves a round of applause. So now, as we draw the curtains on this once again remarkable day, I will invite you once again to take some minutes to reflect on this journey. And I want to start this journey with a very prosaic episode of my own personal life. You know that my daughter, Carolina, she's now 12. She's a great fan of Harry Potter movies. And one of these Sundays, we were sitting down at our sofa back home, and we were both seeing the first of Harry Potter's movies, The Philosopher's Stone. You probably remember more or less how it looks like. And funny enough, we were accompanied by our cat, which is capable of some magical stunts like disappearing without taking notice of where she's gone. She's a female cat, and showing up afterwards without anyone taking notes where she went during that time. So she's really a magical being from that point of view. So I will just play a little bit of that Harry Potter movie for you to look. Maybe you can recognize this. There's some sound lacking, I'm sorry. I need some sound, please. So I'll play it all over again. No sound yet. É o problema daqui? Não.
Não, aqui tá bom.
Okay. This goes better with sound. And since I was wondering for quite a while, I must say, about these closing remarks, after seeing this, I was thinking to myself, it's probably a good analogy to what I want to say. And this is how I got the title for my closing remarks. Probably know the quest for the golden snitch, or the search for the golden snitch. And why? Because it's more or less what we feel as researchers and innovators, is it not? We're always trying to find, sometimes desperately, a golden snitch somewhere in some difficult position over some broomstick or hanging on a rope. And sometimes we are really struggling to get there, and at the end, looking like Harry Potter at the end of this piece, amazed and surprised that we got it, and feeling in awe, and almost feeling it like a magical moment. So I'm sure that, at least I think so, that's the way we feel, and I'm sure that some of us, most of us, do so. And throughout this day, I have sensed that most of you have tried to express how it feels, or at least what it is to feel it, okay? And indeed, during this day, we have explored some exciting research questions and addressed some of the pressing challenges of our time. We have discussed research, innovation, bigger projects, smaller projects, communication, success stories. We have witnessed creativity and transformative solutions. We've seen the convergence of diverse minds, backgrounds, disciplines, each one contributing a tune to the great orchestra of scientific knowledge and progress, and representing not only the strengths of collaboration, but also the hope of unity, and all powered by Ciências. The path ahead is for sure very daunting, these days particularly, but as Nelson Mandela once said, it always seems impossible until it's done. Closing this Research and Innovation Day, I dare you now to renew your spirit of optimism and to reinforce your belief that the work of each one of us matters. Together, like a great scientific orchestra, we are creating a world where prosperity, peace, and sustainability are not just lofty ideas, but lived realities. And indeed, the building of scientific knowledge is something like playing an orchestra, a fine-tuned orchestra. Since I truly believe this, let me now ask you to imagine that you are a solo violin player. A solo player in a magical piece of music. It may be the one that you particularly like. It may be the one that we are about to hear in a moment. In the piece that we will close this day, I dare you to observe on how each player, and especially the violin player, adds their skills to make it a remarkable performance. Like the solo player, each researcher and innovator plays a defining but unreplaceable phrase in the complex orchestra of scientific knowledge. So now, just before we finish, and as I did last year, I invite you to relax, and for the next 6 minutes, before you complain it's too long, let me tell you that it amounts for 1.5 times 10 to the minus 5% of your lifespan if you reach 75 years. So it's not really too long. And reflect on how you like this solo player, and reflect on how, like this solo player, you can contribute with your own and unreplaceable self to knowledge and scientific knowledge. Are you willing to continue to playing your unique tune within this orchestra? Which will be your next note? Dear colleagues, ladies and gentlemen, on behalf of this centenary institution, I wish to thank you for your presence at this Research and Innovation Day. It was a testimony of your personal commitment to the common goal of making a better future a reality. See you next year. Thank you.